Hey everyone, good evening. All right, so right, hey, so we have 8 participants right now. Others may be joining in sometime. By the time others are joining, if anybody has any question, please feel free to ask. Any question regarding yesterday's topics? No? All right, so today we are going to start with a quiz. In this quiz, I'm going to show you some questions, and whoever knows the answer, they can just unmute and answer. However, there is no evaluation for this quiz. This is just for a recap. I'm going to share my screen for this quiz. All right. The first question is on your screen now. So please read the question and unmute and answer. Who introduced the concept of control charts?
It's C, Sir Walter Shewart.
C. All right. What about the others? What do you think? C is correct or not?
Yes, sir. See, sir.
C.
SPC. You only introduce SPC.
Correct. Correct. So Walter Shewart conceptualized SPC, statistical process control, and under SPC we have number of control charts. Right? So correct answer is Walter Shewart. This one, which is not an element of Kano, not an element of Kano.
CTQ, sir.
CTQ. All right. Everybody, I believe everybody says it is CTQ. So in Kano model, we have three categories: must be, need, more the better, and delighters. CTQ is not an element of Kano. CTQ is the correct answer. This one, which of the following is a waste?
All
All
of the
the
above.
above.
All of the above.
All of the above. All right, so that is the correct answer. So unwanted inventory, overproduction, defects, all are wastages. Right? All of the above is the correct answer. This one, who introduced the concept of fishbone diagram?
B. Ishikawa. B. Dr. Kaurosh.
Ishikawa.
All right. So Ishikawa is the correct answer.
One time.
So fishbone diagram is also known as cause and effect diagram, and it is also known as Ishikawa diagram because it was conceptualized by Ishikawa. All right. Next question. Please read the question and answer.
No.
No.
It's done for a process. So company level wise, we cannot say it is a Six Sigma level edge.
All right. No is the correct answer. So this company is running at Six Sigma level for certain process. We can't say that the entire organization is running at Six Sigma level, right? Some processes may be running at Six Sigma level, some may be running at Five Sigma level, Four Sigma level. So we can't say the same thing for the entire organization. Sigma level is process specific. Correct answer is no. This one, which of the following is not a part of Project Charter?
Potential causes.
Obvious.
Potential causes.
All right, potential causes should not be there in the project charter. Apart from causes, solution should also not be a part of project charter because that will lead to bias, right? So potential causes is the correct answer. This one, which is a type of data?
All of the above.
All right, so all of the
All of the
above,
above.
correct answer. So discrete is also known as attribute. So all of the above is the correct answer. All are data type. All right, so yesterday we started with the measure phase, and in measure phase, we discussed regarding data type. Now the next topic that we are going to discuss is measurement of data. Right. So I'm going to share my screen for the measurements. All right. So yesterday we discussed that before doing any statistical analysis, we need to understand what is a data type, whether it is discrete or continuous, because for different type of data, statistical tool will be different. So we discussed that if we are collecting our data by counting something, that data would be discrete data. Count data is discrete data. And if we are collecting our data by measuring something, that data is continuous data. Right? Now, let's say we have collected our data, and after collecting the data, we can measure certain characteristics of data. So for characteristics, generally we measure central tendency or dispersion. Dispersion is variation in the data. For central tendency, we can measure mean, median, mode. So mean is just average, right? Mean is the average. So sum of all the data points divided by sample size, that gives us average or mean. Median is the middle point. So if you're if you sort your data in ascending order or descending order and you take the middle value, that is the median. Right? So for this data set, 37 is the median because that is the middle point. Mode is most frequent data value in a data set. So in our data set, 52 is the most frequent data value. Frequency for 52 is the highest. So 52 is the mode. Now let's discuss regarding dispersion. So dispersion is variation in our data. Right? So let's say for certain process, our target is, let's say, or let's say for accuracy, our target is 90%. Right? For certain process, for the accuracy, our target is 90%, more than 90%. So every day we would not achieve exactly equal to 90, right? So someday it may be 90, someday it may be 91, 89, 80, 88 sometimes 95. So every day there will be some variation. If you want to measure how much variation is there, you can follow these parameters: range, variance, and standard deviation. These are three parameters that we are going to discuss. So first one is range. So range is maximum minus minimum. So if we take this particular data set, maximum is 59, minimum is 22. So 59 minus 22 would give us 37. 37 is the range. So range is just maximum minus minimum. Next parameter is variance. Variance is average difference for all the data points from the mean. Average difference for all the data points from the mean. So if we take this particular data set, so first of all, we need mean, average. So for this data set, average is 40.46. Now we need average difference for all these data points from the mean. That means first we need to calculate differences between these data points and the mean. That means 22 and mean. 22 and 40.46, what is the difference? 26 and 40.46, what is the difference? Right? Then 26 and 40.46, what is the difference? 31 and mean, what is the difference? So we need to calculate the differences. And whatever the differences are, we need to take the average of those differences. and that is known as variance. I'll explain it on Excel as well. That will be easier to understand. I'll give you some example for this. I'm going to share some Excel screen. All right, so in this Excel sheet, I'm going to use one of the case studies, data from one of the case studies. So let's say for case study number 1, not on time delivery case, right? For delivery case, we have collected the data for time. So in column B, we have data for time, delivery time. These are delivery times. So if for these delivery times, if you want to calculate variance, so formula is same as we discussed here. So formula is this. So variance is represented as sigma square, right? It is represented as sigma square, and the formula is summation of x minus x bars whole square divided by n minus 1. This summation is representing sum of all. X is individual data points. So in our data set, individual data points are x's. So this one is x1, x2, x3, x4, and so on. These are x's. X bar is average of the data, right? So whatever the average is, that is our x bar. So you can take the average is 13.66. X bar is 13.66. In the formula, we have x minus x bar. Now we can check what is x minus x bar. So this is x minus x bar, right? So in this column D, we have x minus x bars. In the formula, it is square of it. So we can take the square of it. So x minus x bars whole square we have here in column E. In the formula, it is summation, sum of all, right? In the numerator, you can see it is sum of all. So for all of these, we need to take the sum. Summation is 5167.73. So this is summation, sum of all. In the formula, we have numerator as n minus 1. So n is sample size, right? So here sample size is 300. We have delivery times for 300 deliveries. N is 300. So we just need to put the values here in the formula. So in the denominator, you can see 300 minus 1, sample size minus 1. So when we put these values in the formula, we get 17.28. This is variance. Variance for this data set. And variance is average difference for all the data points from the mean. So this is called variance. And next parameter is standard deviation. And here you can see standard deviation is represented as sigma. Variance is sigma square. Standard deviation is sigma. And standard deviation is just square root of variance, right? So if you take the square root of variance, you would get standard deviation. So in our Excel as well, same is done. So square root of variance, square root of 17.28 is 4.16. This is called standard deviation. Right? So these are 3 parameters that we can use to measure variation in the data. So range, variance, and standard deviation. These 3 parameters are there in statistical analysis. In a lot of statistical analysis, we use standard deviation because of some reasons. We are going to discuss those. Before that, I have one question for everyone. So my question is, out of range and variance, out of these two, which one is better? Range is better or variance is better? Which one is a better measurement?
Variation.
Variance? And any reason why? Why the variance is better?
It will
Because
give the amount of accuracy or error in the data.
Okay, accuracy will be better. And why so? Why the accuracy is going to be better?
outliers can be there, so the one or two values can make the range bigger, but the variance can show.
Correct, correct. So range is just maximum minus minimum. And in most of the cases, maximum and minimum will be outliers. And outliers do not represent the true characteristic of our process. I'll give you some example here to understand it. So let's say in your organization, you are measuring turnaround time for certain process. TAT. Now let's say you have collected the data for TAT for certain days. Day 1, day 2, 3, 4, 5. For last week, you have collected the data. Let's say first day, TAT was, let's say 20. And your target is that TAT should be less than 20 minutes. So first day it was 20. Second day, let's say it was 19, then 19.5. Some day it was 20.1, then again 20. Then on sixth day, let's say turnaround time was 100 because of the power failure. There was a machine breakdown or power failure. Because of that, turnaround time was very high. And on seventh day, what happens? Because some manager merged two teams, right? And the turnaround time became, let's say, only 10, right? So data for two teams was merged and turnaround time became 10. Now, for range, you will consider these two data points, 10 and 100. However, 10 and 100 is because of power failure, and 10 became because of some special reason, right? Special cause. So these are maximum and minimum, and these are the outliers, and outliers are not representing true characteristic of your process. It is not representing your performance, right? So range does not give you very high level of accuracy. In variance, we consider all the data points, not just maximum and minimum, we consider all the data points. So comparatively, variance is better than range. It gives us better accuracy because it considers all the data points. Any question till now?
Sir, just a short query. Can you please once again explain from the Excel sheet how are we getting the X bar value?
X bar is average. X bar is average. AVERAGE, average. And then you can select the data. 13.66. This is the formula, average. Even if you just select the entire data set, you will see the average at the top right
Yeah.
corner.
Okay.
It's average. All right, so let's move forward. All right, so these are three parameters which we can use in our statistical analysis. Later on, we will have a detailed discussion on different types of maybe hypothesis testing, correlation, regression. In different analysis, dispersion and central tendency both are considered. All right. Now let's move forward.
So just two questions. Now,
Yeah, you can ask.
so when we are calculating the variance, it was mentioned
Mhm.
that this is the average of the square differences. So
Correct.
isn't it shouldn't it be should the denominator be n because we have n data points? So shouldn't it be n
Right.
at the denominator?
All right, that's a good question. So why not n? In general, average we consider n, right? We divide it by sample size. All right. So here in statistics, what happens when we are calculating variance or standard deviation for the entire population? For population, in the denominator, we consider only n. It will be only n for variance and for standard deviation both. However, if you are calculating variance or standard deviation for your sample, not for the population. For sample, we use n minus 1 as a standard. So it's a standard practice that is done. So n minus 1 is used for sample. And this n minus 1 is called degree of freedom. Degree of freedom in statistics, right? So it is called degree of freedom. For sample, it is used. For population, it is not used. For population, I mean, n is used, sample size.
Okay, thank you.
Okay.
Thank you.
All right, now let's move forward. So another good thing about standard deviation. So first good thing about variance and standard deviation that they consider all the data points, right? Another good thing about standard deviation is the unit of measurement remains the same. So if your data is in, let's say, minutes, let's say delivery time is in minutes, your standard deviation will also be in minutes. That's a good thing about standard deviation, and that's why in a lot of statistical analysis, we consider standard deviation for dispersion. Now, let's say you have measured central tendency, dispersion, then we can also do some graphical analysis, right? By looking at the distribution of the data as well, we can make some inferences, right? So anybody who can tell which tool is it? So here we are looking at the distribution of the data, but which tool is it?
Histogram.
Histogram, correct, correct. So if you create a histogram with your data, you can tell about how the data is distributed. Data distribution you can judge. Now let's discuss about distributions. So if your histogram is looking like a bell-shaped curve, right? If your histogram is looking like a bell-shaped curve, that means the data is normally distributed. It is called normal distribution. Anybody who is familiar with normal distribution? What is normal distribution? Any thought?
That data
Hey sir,
points
hi,
are
I'm audible.
Yes, you are audible. Yes, Vaibhav.
Yeah, so in a normal distribution, basically, majority of the values are around the mean, and as we go towards the extremes, the value tapers. The let's say the occurrence of that particular instance tapers down.
All right. All right. That's correct. Yes. Any
It's
other
kind
thought,
of a,
Harsh?
kind of an inverted U-shaped curve where the means the central value is the maximum value, and when we move towards the extreme left or right, then the value goes on decreasing.
All right. Frequencies will decrease. All right.
Yeah.
All right. Any other thought? Anyone? What is normal distribution? And why do we call it normal? Why don't we call it abnormal distribution? Any thought?
Sir, because in normal distribution, the mean, mode, and median, all three are same. It coincides at the center. And
Okay.
the best part is that it will give you the probability values of the area under the curve will give you the probability values of that range. So the
All right.
specific part is mean, mode, median is equals. So that is the mean.
All right. So these are characteristics of normally distributed data. That's correct. Right. So the mean, median, mode, all three will be equal or close to each other. Right. So these are the characteristics. But why do we call it normal? Any thought? Why not abnormal distribution? All right, so I'm going to explain that. So in the real world, when everything is normal, nothing is wrong, everything is normal, from our processes, we tend to get this kind of distribution. When everything is normal, we get this kind of bell-shaped curve. That's why we started calling it normal distribution. In normal scenario, we get normal distribution. When everything is normal, we get normal distribution. I'll give you some example for this. So, um, give me just one moment. I'll share my screen again. I would use the same example that I was talking about regarding turnaround time. So let's say in your organization, you are measuring turnaround time for certain process, and the target is again same. The turnaround time should be less than 20 minutes. Let's say you have collected the data for the last 1 week. I'm going to show you 3 scenarios, and you need to tell me if this scenario is a normal scenario, if it is going to happen in a normal week. So I'll show you the performance of this team in 3 weeks, and you need to tell me which week is normal, which week is not normal. So week A. So let's say when you are collecting data for week A, you see that on day 1, turnaround time was 20. Day 2, again 20. Day 3, again 20. Every day, 20. Now, what do you think? In a normal week, are we going to expect this kind of performance? Would you expect it in a normal week when everything is normal? Will you get this kind of performance?
No, sir.
No,
No, right?
because every day we cannot produce the same.
Correct, correct. So every day it will not be exactly same, right? So this is not a normal scenario. So if you draw a histogram with this data, you will not get a bell-shaped curve, right? It will be a flat kind of distribution, right? It is not normal distribution. Scenario B, let's say first day it was 20, second day it was 19, third day it was 20.5, next day it was 19.5, then 21, then 19, 18.9. What do you think? In a normal week, would you expect this kind of performance?
Yeah, Gaurav. This is a
It may
possibility in
happen,
a
right?
normal week.
It may happen in the real world. Some day we underachieve, some days we overachieve, right? So fluctuation happens on both sides of the mean, right? In this case, if you draw a histogram, that will show you a bell-shaped curve. Fluctuation is happening on both sides, right? And most of the times you will be uh, close to the mean, right? Scenario C. Let's say first day 20, second day 19, then 21, then 100, then 50, then let's say 40, only 10. Would you expect this kind of performance in a normal week?
No.
No.
No, right? You would not expect outliers, right? So that means when we add outliers in our data, data becomes non-normal, right? Outliers represent special cause variation. So there are two types of variations: common cause variation and special cause variation. Common cause variation is which is there in week B, right? Common cause variation. Every day there will be ups and downs. However, if there is too much variation, that indicates that there is something wrong. That is special cause variation, right? And these are called outliers. So we call this kind of distribution as normal distribution because in the real world, when everything is normal, we get bell-shaped curve. All right. Any question till now? All right. So the next one is right skewed. So if the tail of your histogram is longer on the right hand side, it is called right skewed distribution, which is also known as positively skewed. And let me tell you, there is nothing positive about positively skewed. It is just about the location of the x-axis. X-axis on the right hand side is positive. That's why we call it positively skewed. If the tail of the histogram is longer on the left hand side, we call it left skewed distribution, which is also known as negatively skewed. And we call it negatively skewed because of the x-axis on the left hand side, it is negative. And whenever you get skewed distribution, my suggestion will be to check the validity of the data. So a lot of times what happens in Six Sigma projects, we get manipulated data. If somebody is manipulating the data, if somebody is removing outliers from the data becomes skewed. I'll give you some example for these two. So let's say you have asked some process owner to share the data for efficiency. Let's say target for efficiency is 50%. Now let's say some days efficiency was, let's say 20% or maybe 10%, 30%. So from the left hand side, that process owner is removing those outliers. Since they are removing outliers from the left hand side, data becomes right skewed. Another example. So let's say the CTQ is error percentage. Target is less than 8%. Error percentage should be less than 8%. Now let's say someday error percentage was 20%, 25%. So that smart manager is removing those outliers. So if they are removing the data from the right hand side, data becomes left skewed. So whenever you get skewed distribution, always check the validity of the data. It may be an indication that somebody has manipulated the data, but not in 100% cases. Sometimes it may be true characteristic of your process as well. That is also possible, right? If let's say process is improving, process is deteriorating, in those cases, you would get skewed distribution. Now, next one is uniform distribution. So if let's say there is no variation or very little variation is there, in that case, you would get uniform distribution. Example can be data from automated processes, right? From automated processes, you would get uniform kind of distribution because variation will be very, very low. So you would get uniform distribution. For example, let's say from some water purifier, you are getting, let's say, 5 liters per hour, right? Every hour, 5 liters. Right? So distribution will be uniform. Next is bimodal. So if in your data set, there are multiple modes. So previously we discussed about mode. So let's say in the same data set, if there are two modes. So right now, mode is 52 because frequency for 52 is highest. If let's say, if we are adding another 37, now for 37 as well, frequency is 3. Now we have two modes. One mode is 52, another mode is 37. So if there are two modes in our data distribution will be bimodal. Example can be, let's say, we are getting productivity data for multiple machines. And let's say two machines are the best, right? There are two machines for which production is highest. So there will be two modes. Another example, let's say we have collected data for sales, right? We are collecting the data for sales for pan India. For all the cities in India, we have collected sales data. If let's say sales numbers are highest in Delhi and Mumbai, right? In Delhi and Mumbai, there are highest numbers for sales. So there will be two modes, one mode for Delhi, one mode for Mumbai, right? So these are different types of distributions that we can come across. And by looking at distribution as well, we can make some inferences. Any question here? And as we discussed,
Yeah, I
yes.
couldn't hear the last one. Bimodal distribution. Can you just give a summary for that?
Okay, bimodal distribution you will get if there are two modes. Within your data set, if there are two modes, you will get bimodal distribution. So previously we discussed about this example, no? So 52 is the mode. However, if let's say frequency for 37 is also 3, so there will be two modes. One is 52, another one will be 37. If we add another 37 here in this data,
Yeah.
so there would be two modes, 52 and 37. So if you create a histogram, it will show you two modes,
Two peaks. Got it.
two
Got it.
peaks,
Thank you.
correct. All right. So these are histograms as we discussed, and I believe most of you must be already familiar with histogram. So for histogram, we are going to do some activity as well, some exercises. However, I believe all of you must have created histogram. It is very simple. In Excel, you just need to put the data, go to insert, select histogram. So later on, we will do the exercises. So in histogram, what all inferences do we get apart from distribution? Anyone? What all inferences can we draw by looking at histogram?
Range we
Anyone?
can get. Uh,
Range? Anything else? Anyone? All right. So by looking at histogram, we can tell, first of all, distribution, right? So whether it is normal or skewed, that we can tell. And histogram on the x-axis, it represents classes or categories or intervals, right? X-axis represents classes or categories. Y-axis represents the frequency. So by looking at histogram, we can tell in which class frequency is highest, lowest, above average, below average. All these are inferences we can draw by looking at histogram. Right? And later on, we will do some exercise as well for histogram. Any question here?
Gaurav, right. I had a bit of a confusion between right skewed distribution and left skewed distribution. Mainly because I found it a bit counterintuitive. So,
Mhm.
what I understand by a skewed distribution, it is more towards that side. So, if I say it is right skewed, more of my values are towards the higher end. But in the diagram which you had showed, it is tapering towards the right side. So, the values are lower on the right side. So, I found that a bit confusing.
Okay. Values are more, but the frequencies are low in the right skewed. Frequencies are low, values are more on the right hand side. That is right skewed. So by the tail, you can also understand if tail is longer on the right hand side, that is right skewed. If tail is longer on the left hand side, that is left skewed.
All right, got it, got it.
All right. Any further question, anyone, regarding histogram? So we discussed about normality. Now let's discuss some characteristics of normal distribution. So if the data is normally distributed, it shows us a bell-shaped curve as we discussed, and that bell-shaped curve will be symmetrical on both sides. Left-hand side will be the mirror image of right-hand side. Uh, 50% data will be on the left hand side, 50 on the right hand side. If data is normally distributed, mean, median, mode, all three will be equal or close to each other. And if the data is normally distributed, we can make some predictions as well with regards to data, with regards to process performance. Some predictions are also possible by using the characteristics of normally distributed data. And that specific characteristic is given in point number 1. So point number 1 says it links frequency distribution to probability distribution. One of you also said that there will be fixed probabilities. We can make some predictions for probability, right? So what happens if the data is normally distributed? Its frequency graph correlates with the probability graph. That means there will be fixed frequencies. Within specific standard deviation, there will be fixed frequencies, and those frequencies are given here. So if the data is normally distributed, what we observe within plus minus 1 standard deviation, within plus minus 1 standard deviation from the mean, within plus minus 1 standard deviation from the mean, 68% data is covered. Within plus minus 2 standard deviation, 95% data is covered. Within plus minus 3 standard deviation, 99.73% data is covered. So it's a kind of prediction we can do. So when we say process is running at 6 sigma level and there will be only 3.4 defects in 1 million opportunity, that is also a prediction, right? So in capability calculation, we use these parameters, right? So the characteristics of normally distributed data can be used to make predictions. I'll give you some example as well for these distributions, 68, 95, 99.73. I'll give you one example for this. So let's say for this particular session, we are collecting data for height. We are collecting data for height for all the participants here in this session, right? So when we collect the data for height, height data comes out to be, let's say, average height. Average height is 165 centimeter. This is average height. Now let's say when we calculate standard deviation comes out to be, let's say, 1. Just to keep it simple, I'm keeping standard deviation as 1. So plus minus 1 standard deviation. So plus 1 standard deviation will be mean plus 1 standard deviation, 166, minus standard 1 minus 1 standard deviation, mean minus 1 standard deviation. So within this range, plus minus 1 standard deviation, within this range, we can say that 68% participants here would have their height between 164 and 166 centimeters. It's a kind of prediction we can do. Right? If the data is normally distributed, we can make these predictions. Right? If there are 100 participants, 68 participants would have their height between this range only, 64 and 166. Then plus minus 2 standard deviation. So it's 1s. Then 2s plus minus 2. So mean plus 2 standard deviation. Standard deviation is 1. 2 standard deviation will be 2. Mean minus 2 standard deviation. So we can also say if there are 100 participants, 95 participants will have their height between this range, 163 and 167. It's a kind of prediction we can do. right? So these parameters are used in statistical analysis to make predictions, right? And these characteristics are used in hypothesis testing as well. Later on in analyze phase, we will discuss about hypothesis testing. Any question here? All right, now let's move forward. So previously we discussed that to check the normality, we can use histogram. If the histogram looks like a bell-shaped curve, we can say data is normally distributed. However, when we look at the histogram, that is just graphical analysis. By looking at histogram, we may not be sure about normality, right? So there is a test called Anderson-Darling test that we are going to do in some time, which is done to check the normality of the data. So this test in some time we are going to do. All right. So next tool that we are going to discuss is boxplot. Anybody who has used boxplot before? Boxplot?
Yes, yes, sir. I already used this with my data analysis.
All right. How does it help?
So first part is that it will tell me the percentile values, how much the things are there, and outliers are also it can show me the outliers very quickly, because if this is within the interquartile range, it's like the standard methods for that. So that is the box plot help me. And second point is that it will show me where the most of my data has been concentrated, like
All right.
within which quantiles my data is there.
All right. All right. All right. Thank you for sharing your thoughts. So boxplot is used for comparison. It's a very good tool for the comparison. Let's say you want to compare your team's performance and your competitor's team performance. For comparison, histogram may not be the best tool, right? For comparison, boxplot is a good tool. Now, to create boxplot, you can use maybe Excel or maybe Minitab, SPSS, Statistica, JMP. A lot of softwares are there, or you can use Excel as well. I mean, Excel you can use for Excel. You just need to put data in one column, go to insert, and then select boxplot. It will create boxplot. However, in Excel, it is called as box and whisker plot. So you can select that and create a box plot manually. You don't have to do it. However, I will explain for the reference. I'll explain how Excel is going to create box plot for you. The background calculation I will tell you. So when we create box plot by using any platform, by using any software, what those platforms or softwares are going to do? First of all, it will sort your data in descending order. So let's say 100 points you have, 100 data points. It will sort that data in descending order. It will sort that data in descending order. After sorting the data in descending order, it divides the data into 4 quartiles. Quartile 1, 2, 3, 4. Quartile 2 is the median. So previously we discussed that median is midpoint. So to identify a median, what it does, it divides the entire data into 2 halves. Right? Midpoint is median. It will divide the data into 2 halves. It is median. Median is quartile 2. It is quartile 2. If you divide the upper half into 2, that will be quartile 3. If you divide the lower half into 2, that gives you quartile 1. Manually, you don't have to do it. Just for the reference, I'm explaining. So it divides the data into 4 quartiles, quartile 1, 2, 3, 4. So every quartile will have 25% of the data points. So if there are 100 data points, every quartile will have 25, 25, 25, 25. And by looking at box plot, we can make some inferences or we can do the comparison based on 2 parameters. So here we consider 2 parameters. First one is IQR. IQR is quartile 3 minus quartile 1. It's a kind of range. Previously, we discussed that in normal range, we consider maximum and minimum. And maximum and minimum may be outliers. So IQR is a better measurement. Here in IQR, we are not considering maximum and minimum. We are considering the quartile 3 and quartile 1. So it's a kind of range. And range represents variation. So if IQR is high, that means variation is high. Let's say you have collected your team's performance data and your competitor's team's performance data. Let's say in your team, IQR is 1. In your competitor's team, IQR is 5. That means your performance is better. That means variation is low in your team. Low IQR shows low variation. So you can say my performance is better because my IQR is low. Low IQR represents low variation. So based on IQR, we can do the comparison. Next comparison we can do based on number of outliers. So in box plot, any data point that goes beyond upper adjacent value and lower adjacent value, those data points are called outliers. I will explain regarding adjacent values as well. However, manually you don't have to do it. I'll give you the formula though. So formula for upper adjacent value is quartile 3 plus 1.5 IQR. Right? Quartile 3 plus 1.5 IQR. Manually, you don't have to do it. This is just for the reference. Lower adjacent value is quartile 1 minus 1.5 IQR. So this is how Excel is going to calculate upper adjacent value, lower adjacent value. And any data point that goes beyond these values, it will highlight those outliers. And based on number of outliers, you can do the comparison. Let's say in your team, there is 0 outlier. In your competitor's team, there are 5 outliers. So you would say my team performance is better because I have 0 outliers. My competitor has 5 outliers. So based on 2 parameters, we can do the comparison, IQR and number of outliers. Any question here?
So the question is arising in my mind. It's written here, each segment represents 25% of the data points.
Data points, right?
So how is it? Can you please explain?
So we are dividing the data into halves. And first, the entire data we are dividing into half. That is median. This is quartile 2. Half means 50, 50, right? This
Okay.
is 50, this is 50. Let's say total data points are 100, so 50, 50. Now, again, we are dividing the data into half. So 25 and 25.
Okay, means we are doing this process initially, right?
Yes.
Okay.
Yes.
Got it.
All right. Any further question, anyone? Based on 2 parameters, we can do the comparison. And we are going to do exercise as well for box plot after some time.
When we are calculating Q3 and Q1, when we say between Q3 and upper adjacent value at 25%, are we considering outliers also be at 25% or are they excluded?
Okay, so 25% will include the outliers as well. It will include the outliers.
Okay.
Because we are dividing the entire data set. That will include the outliers as well. Now let's move forward. For box plot, we are going to do some exercises as well. For histogram, box plot, for everything we will do the exercises. I hope everybody has received LMS access. Have you guys received it? LMS?
Yeah, Gaurav, I've received it.
Yes.
All right, so we are going to use LMS today for our analysis. All right, now the next topic that we are going to start is MSA, Measurement System Analysis. Anybody who has done MSA, Measurement System Analysis? MSA? Measurement system
No.
analysis. All right.
So we did it when we are like setting up the Apple production lines. So basically, we are doing the it's
Mhm.
basically we are calibrating our machines to set up what are the measurement standards that we need to do. So it's like
Mhm.
repetitive samples we have to take, and we have to take the data from that samples and then check like where our machine is, and it's calibrating the machine's normal form, like measurement system analysis, making the measurement system capable for about like.
Correct. So for calibration, it is used. Correct. So in measure phase, as we discussed earlier, our objective is to measure the baseline, measure the current performance, measure the current sigma level, right? So before we can calculate the baseline, we need to make sure our measurement system is working fine. It should not happen that our measurement system is faulty and we are calculating the sigma level, because that sigma level will be incorrect. If our measurements are incorrect, sigma level will also be incorrect. I will give you some specific example here. Let's say your CTQ is error percentage, and when you observe your quality checker, you see that your quality checker is not doing actual inspection. They are just creating reports. Every day in the report, they say accuracy is 100%, error percentage is 0%, right? So you will not rely on the reports given by this quality team, right? Right? We need to validate. We need to validate our measurement system. Quality team is our measurement system, right? Quality team is a part of our measurement system. Whatever equipments we use for the measurement, that is a part of our measurement system. So before setting up the baseline, before calculating the sigma level, we need to validate our reports. We need to validate our measurement system. Uh, I'll give you some hypothetical example. Let's say there is a tailor. There is a tailor who is going to take measurement of his client so that he can stitch a suit for the client. Before taking the measurement, the tailor would make sure that his measurement tape is fine. It should not happen that first 2 inches are missing and he's taking measurement, right? So we also need to validate our measurement system, just like that tailor, right? So whatever equipments for measurement we are using, whatever quality team we have, we need to validate that system. We need to validate our measurement system. Quality team is also measurement system. They measure the quality, right? After measuring quality, they release their reports, right? Every day they tell accuracy is this much, error is this much, quality is this much, right? So quality team is also our measurement system. So we need to validate our measurement system before calculating current sigma level. And that's why we do MSA, measurement system analysis. So you can see here why we do it, to verify the adequacy of measurement system, right? We need to make sure our measurement system is fine. It should not happen that measurement system is faulty, and with that faulty measurement, we are calculating the sigma level. All right. So for MSA, we need to understand certain key points. Let's discuss those key points, and then we will discuss the method for MSA. So let's discuss these key points here. Okay. So bias, first one is bias. Anybody who can give any example for bias for the measurements or for inspection? Have you observed bias anywhere in inspections? Any bias in measurement? All right, I'm going to give you some examples. Let's say you are going to some general store or maybe a vegetable shop, fruit shop. Now, in that shop, let's say there is a weighing scale. Even if you are not keeping anything on the weighing scale, it says 50 grams. Sometimes it happens, no? So even if you don't keep anything, it says some grams, 50 grams, 100 grams, 10 grams. That means there is a bias. Whatever you measure, it will add those many grams. That's a bias. It will impact the accuracy. Another example, let's say your quality checker is doing some inspection. In the product, there is some flaw, but quality checker says 19-20 का ही फर्क है. I'll pass it. Right? There is very little variation. I'll pass it. That's a bias. It will impact the accuracy. Or let's say when your quality checker is measuring this product, let's say product length is 9.9 centimeter and quality checker is mentioning in the check sheet that it is 10 centimeter. They are rounding up, right? Actual is 9.9. They are rounding up saying it is 10 centimeter. Rounding up is a bias. It will impact the accuracy. So any bias should not be there in our measurement system. It will impact the accuracy. Any question here regarding bias?
Any kind of negligence in the process of calculating the quality, or
That
is
will also
that also
impact the
bias?
accuracy. Correct.
That is
Correct.
also bias.
Yes. That will impact the accuracy. All right. Next is stability. So whatever our measurement system is, whether it is quality checker or it is some equipment, they should be stable. Stable means they should not get impacted by the external factors. Right? Every time they should give the same result. That is called stability. I'll give you some examples here. So let's say you are measuring weight of your gold ring, right? In some jewelry shop, you are measuring weight of your gold ring. When you keep your gold ring on the weighing scale, it says, let's say 3 grams. In the meanwhile, somebody switches on the fan. After switching on the fan, it says 3.5 grams. That means this weighing scale is not stable. It should not get impacted by the external factors. So that's why in jewelry shops, you would see they keep the weighing scale in some glass cabinet, closed cabinet, right? To make it stable. It is true for quality checkers as well. They should also not get impacted by the external factors. Let's say our quality checker in the morning, quality checker is in good mood. So he is passing all the products. Now after lunch break, he is not in good mood. So he's rejecting everything. So that should not happen, right? He should not get impacted by the external factors. He should be stable. So whether it is equipment or quality checkers, they should be stable. Next is sensitivity. Anybody who can explain what is sensitivity with regards to measurement system?
Sensitivity means in example weight balance 100 gram, 200 gram, accuracy. The standard is equal to percent.
All right. Any other thought, anyone? Sensitivity for equipment or operators or quality checkers. Sensitivity.
Is it the number of decimal points or
Decimal points. That is correct, yes.
Sir, it can be said as means a highly means having a more least count or a more resolution in any data.
Correct.
That
Correct.
can be said to be more sensitive.
Correct. Correct. So sensitivity is regarding the least count, regarding
Yeah.
the least variation that you can identify, right? Regarding the least variation you can identify or low variation that you can identify. I'll give you some example to understand it. Let's say there is a truck driver who wants to check weight of his truck. So that truck driver is taking his truck to some weighing bridge where he can take the measurement, take the weight of the truck. Weighing bridge or weighing scale. In Hindi, it is called Dharam Kanta. So that truck driver is taking his truck to some weighing bridge. When he parks his truck on the weighing bridge says weight is 20 tons. 20 tons. Now truck driver steps down from the truck. Still the measurement is 20 tons. There is no difference. That means this weighing bridge is not sensitive enough to measure weight of this truck driver. Not, let's say that truck driver wants to check his weight. So he is going to some hospital OPD, right? So in that hospital OPD, he stands on the weighing scale. Now weighing scale says 50 kilograms. Then he removes his uh, ring. Let's say he's wearing a gold ring. He removes it. Still, that weighing scale says 50 kilograms. That means this weighing scale is not sensitive enough to measure in maybe grams and milligrams. Then he's taking this ring to some jewelry shop. In jewelry shop, they can measure in milligrams. They have better sensitivity, higher sensitivity, right? So sensitivity is dependent on least measurement we can do or least variation that we can identify. With regards to quality checkers as well, it is true. Some quality checkers are known to be very, very strict quality checker. Even if there is very low level of variation, some minor flaw is there, they will identify it. That means they are sensitive. So it is regarding least variation that we can identify. Any question here? So with regards to inspection as well, I'll give you one example. Let's say there is a paint company. And before that, just a disclaimer, it is just a hypothetical example. In the real world, it is not going to happen. So there is a paint company where they are doing some R&D. So in their R&D department, they are, let's say, creating some new colors and shades for their paint. So they have made some samples and they are giving those samples to two quality checkers. And the quality checker needs to identify color and the shade. So that quality checkers need to do. Let's say one quality checker is male, another one is female. Now let's say this R&D department is giving some samples to these two quality checkers. Let's say first sample is a shade of pink. So male quality checker says it's pink, right? Generally it happens, no? Males would not have that kind of knowledge regarding colors, right? So male quality checker says it's pink color. Now when this team is giving these samples to female quality checker, now female quality checker says this one is magenta pink, fuchsia pink, this one is baby pink, hot pink, bubblegum pink. That means she can identify more variation. She is more sensitive towards colors, right? So sensitivity is dependent on least variation we can identify or least measurement we can do. Any question here?
Just to be sure that if the bias is more, that is a bad thing. If the stability is less, it is a bad thing. But for the sensitivity, what should be the case? If it is higher,
Higher
it
the
is
better.
bad, right?
Higher the
Higher the
better.
better.
Yes.
Okay.
All right. Now the next one is repeatability and reproducibility, which I'm going to explain after some time. First, I want to explain variation. So in any measurement, in any organization, when you are getting reports, let's say quality report every day you are getting. So in your report, there will be variation. So let's say your CTQ is accuracy percentage. Every day you are getting report where you get accuracy percentage. So every day in your report, there will be some variation. Someday accuracy may be 95%, 90%, 94%, 93%. So that variation which you find in your reports, that is called overall variation. In this variation, there are two components. Part to part variation, which is actual variation in the process, And measurement system variation, which is not actual variation. Measurement system is the variation which has been caused by the measurement system itself. I'll give you some example for this. Let's say we are asking our operator to cut steel pipes. Let's say our operator needs to cut steel pipes and the target length for steel pipe is, let's say, 10 centimeter. Target length is 10 centimeter. Now, what do you think when your operator is cutting steel pipes? All the pipes will be exactly equal to 10.00 centimeter, or there will be some variation?
There will be variation.
Some variation may be there, right? So some lengths may be 10.01 centimeter, 10.02 centimeter, 10.1 centimeter. Some variation is bound to happen. That variation is called part to part variation, which is actually there in the process. It is called part to part variation. Then measurement system variation is variation which has been caused by the measurement system itself. Now let's say all these pipes that your operator has cut. Now we are giving these pipes to some quality checker. Let's say the actual length for certain steel pipe is 10.1 centimeter. 10.1. Now your quality checker is measuring it. Actual length is 10.1. Now your quality checker says length is 10 point, let's say 2 centimeter. So what this quality checker is doing? He is adding some more variation, and this variation is known as measurement system variation. This is not actual variation in the process. This variation is caused by measurement system itself. So under overall variation, we have two types, part to part and measurement system variation. Under measurement system variation, we have two types, repeatability and reproducibility variation. Anybody who has heard about these terms? Repeatability and reproducibility. In calibrations, we use these terms.
Sir, if I take a guess, I think repeatability would be kind of a precision, means how precise the value is, means every time when a person is measuring something, so up to the exact value, how much times he's getting that value. For
Correct.
example, if you have given the example of 10 centimeters, so he's approaching nearby 10 centimeter and getting a precise value. So that can be, I guess, repeatability.
Correct. For one operator, right?
Yeah.
Same operator. All right. That's correct. Any other thought, anyone?
Sir, for reproducibility means if person is performing the analysis, then it should be reproducible. Means if he gets a result 99.5 and another time he gets 99.1%, means it is a variation. So if it is under the allowable variance, then it is okay, but it should be reproducible. Results should be reproducible.
All right. So I'm going to explain it now. So repeatability variation is where one operator, same operator is measuring same part and there is a variation. That is repeatability variation. Let's say you are asking me to measure length of this particular product. So right now I'm saying it is 10 centimeter. Then again, after 2-3 hours, you're again giving me the same product. In the second trial, I'm saying length is 10.5 centimeter. So first I'm saying 10, in the second trial 10.5 centimeter. There is a variation. Same operator is giving different result. This variation is called repeatability variation. So when same operator is measuring same part and there is a variation, that is repeatability variation. Reproducibility is where different operators are giving you different results. Let's say I'm saying the length is 10 centimeter. Then let's say Amar says length is 11 centimeter. So there is a variation. Different operators are giving you different results. That variation is known as reproducibility variation. Ideally, these variations should not be there, but in the real world, it may happen. Any question till now? Another example, let's say there is some product. And you are giving me the product, and I am rejecting that product. Again, you are giving me that product after some time. In that trial, I'm accepting it, I'm passing it. That means there is repeatability variation. Same operator is measuring same part, and there is a variation. When different operators are giving you different results, let's say I am passing a product, and same product, somebody else is rejecting that product. That is reproducibility variation. So repeatability is for one operator, reproducibility is for multiple operators. So your operator should repeat the same measurement, and all the operators should give you same results. Everybody should be on the same page. That is the intent of measurement system analysis. Right? Intent is to reduce measurement system variation. It should not be there. So here you can see one question is given. Which variation component do we want to be larger? Which one? Part to part or measurement system variation should be larger? Out of these two, part to part and measurement system, which one should be larger?
Part to part.
Part to part should be larger. Measurement system variation should be very, very low, because from your quality team, you will not expect this kind of variation. Right? So operator is going to show some variation, but quality checker should not show high level of variation. Right? So under reproducibility, again, we have two types. One is operator reproducibility. So same as we discussed earlier. So different operators are giving different results because they are not on the same page, right? They have different understanding. Or let's say some operator is not trained, some operator is new, another one is old. So they are not aligned with each other. So they are giving us different results, and it may be a fault of your operator. Because of the operator, there is this reproducibility variation. Operator by part interaction is the variation which has been caused because of some specific part. Let's say we are producing 10 different products. For 9 products, there is no variation. There is a new product for which there is a variation. So there is a new part, new product for which, let's say, we have not given training to our operators. They don't know how to do inspection for this new product. So it may not be the fault of our operator. It is some specific part which is showing some variation. Right? So that is called as operator by part interaction. It may not be the fault of your operator. It is because of some specific part. I'll give you some product based example. Let's say there is a garment manufacturing firm where we are producing, let's say, t-shirts or shirts. So for shirts, everybody is already trained. They are not showing any variation for shirts. But let's say today we have launched a new product, which is denims. So for denims, they are showing some variation because they are not trained. It's a new product for them. So for denims, there will be variation. For t-shirts or shirts, there will be no variation. That is called operator by part interaction. For a specific part, there is a variation. I'll give you some example from service as well, from service-based company. Let's say there is a call center. In that call center, let's say they answer all the calls in Hindi and English. One fine day, there is a customer and the customer is not good with Hindi or English. Customer is speaking, let's say, French or Spanish. Now, let's say when this customer is calling, first of all, agent would have hard time understanding the customer and supporting the customer. Then if the same call is audited by the quality checkers, So different quality checkers may have different point of view regarding this one call, not for each and every call, but for this one call, they will have differences in the opinion. Let's say first quality checker says, this is not my agent's fault that the call was not resolved. It was because of the customer. My agent did whatever he could do. He did his best. So I'm marking my agent as 5 out of 5. I'm giving him full marks. 5 out of 5. Second quality checker may say that this agent should not have supported the customer. So for specific call, there is a variation that is called operator by part interaction. It may not be the fault of your operator or quality checker. It may be some specific part for which variation is there. Any question here? So in MSA, measurement system analysis, we get to know what type of variation is there, whether it is repeatability variation, reproducibility variation, or maybe operator by part interaction. So we do this bifurcation so that we can know what is the root cause for the variation. Once we know the root cause, we can take corrective action and preventive action. So that's why we are understanding these types of variations. Now let's discuss the methods for MSA. So two methods we are going to discuss here. So one method is for continuous data, one for discrete data. So if data type is continuous, we can use variable gauge RNR study. This is for continuous data. If the data type is discrete, in that case, we use attribute agreement analysis. These two methods we are going to discuss, and we will do exercises as well for these two methods. Let's discuss regarding continuous data first. So if the data is continuous, we can do gauge RNR study. This is the method for MSA for continuous data. For gauge RNR study, there are certain minimum requirements that we need to check before doing MSA. So the requirements are, there should be at least 2 operators. There should be at least 10 parts. That means sample size should be at least 10. Then there should be at least 2 trials. We need to give one part to one operator at least twice. At least 2 trials should be there. Why do we need 2 trials? Why would you give one part to one operator twice?
To measure the repeatability variation.
To measure repeatability variation. Correct. So we would give one product to one operator so that we can check how much repeatability is there. Right? And we need 2 operators. That means we would give one part or one product to 2 operators so that we can check how much reproducibility variation is there. Right? So these are minimum requirements for gauge RNR. There is another requirement, masking. So our operators should not know that we are giving the same part again. In the second trial, they should not know this is the same part. Otherwise, they will give the same measurement. Right? So masking is also needed. So these are minimum requirements for gauge RNR. And for gauge RNR study, since it is statistical analysis and we cannot expect everybody to be masters in statistics or mathematics, in organizations, we use different softwares for the analysis. So softwares may be Minitab, SPSS, Statistica, JMP, a lot of softwares are there. However, there are fee as well for these softwares, right? License fees are there. So here for this session, for this program, what we are going to do, we are going to use a template, a calculator for the same exercises. I mean, whatever exercises you would do on Minitab or Spaces or any platform, same exercises you can do by using a template which we are going to provide. And not only template, you can also use GenAI. So nowadays people have started using GenAI for statistical analysis as well. right? So we don't have to be the master in statistics or mathematics. So for decision making, we are discussing, right? For decision making, we can use these solutions, right? But we need to know which tool to use in which scenario, right? Now let's discuss what we get as an output from Gauge RNR study. So the output from Gauge RNR study will be with regards to three parameters. In the output, we get three parameters. First, I will explain these three parameters, then I will give you the benchmarks as well. So these three parameters are study variation, percentage contribution, and number of distinct categories. First, I will explain these parameters. So study variation and percentage contribution. Both of these are actually contribution of measurement system variation in the overall variation. Contribution of measurement system variation in the overall variation. However, for study variation, the unit of measurement that we use, that is standard deviation. So you can see here, study variation is based on standard deviation. And for percentage contribution, we use variance, right? Both are telling the same story. Both are telling what is the percentage of measurement system variation in the overall variation. It is just that measurement parameters are different. So for study variation, we are using standard deviation. For percentage contribution, we are using variance. Right? So these are contributions of measurement system into overall. Now, third parameter is NDC, number of distinct categories. If you are using annotation, please don't use it. So NDC is number of distinct categories that your measurement system can identify. I'll give you some example for this first. Let's say your operator, when your operator or quality checker is doing inspection, after inspection, they are saying this product is good, this is bad, good, bad, good, bad. That means there are two categories. They can identify two categories. Or let's say some other quality checker is doing some grading. So grade A, B, C, D, E. So there are 5 categories, A, B, C, D, E. So number of categories, distinct categories that our quality team, that our operator can identify, that is called distinct categories, number of distinct categories. Now let's discuss the benchmarks or threshold values. So whenever study variation is between 0 and 10% and the percentage contribution is less than 1, there is unconditional acceptance. That means our measurement system is fine. We don't have to take any corrective and preventive action. By using our measurement system, we can calculate the sigma level. We can set up the baseline, right? We don't need any action. If study variation is between 10 and 30% and the percentage contribution is between 1 and 9%, there is a conditional acceptance. That means based on the criticality of the measurement, we can either accept our measurement system or reject our measurement system. I'll give you some example for this. Let's say we are measuring weight of trucks at some toll plaza. So that measurement will not be very critical. So even if study variation is around 30 and the percentage contribution is around 9%, we would accept it. However, if you are measuring weight of some salts to make some drug in pharmaceutical industry, that will be a critical measurement. So even if study variation is, let's say 11 or 12, you will reject it, right? So based on the criticality of the measurement, either you will accept it or reject it. You have to take a business call. You can discuss it with the subject matter expert and decide. Third scenario, if study variation is greater than 30% and the percentage contribution is greater than 9%, there is no acceptance. Even if the measurement is not critical, still we need to reject it. Third parameter is NDC. So NDCs should be at least 5 or greater than 5. 5 is the least, right? Greater than 5 is better. it should be at least 5. If it is not 5, we have to reject the measurement system. And NDC will be dependent on sensitivity. When sensitivity increases, you will be able to identify more categories, right? So it is dependent on sensitivity. If NDCs are less than 5, you will increase the sensitivity. Let's say to measure time, we are using analog watch. So sensitivity will be low. If NDCs are less than 5, you would use digital watch. So sensitivity will increase. So these are the threshold values. Based on that, we can accept or reject our measurement system. If we are rejecting the measurement system, in that case, it becomes our responsibility to correct it. And to correct it, we need to identify what is the type of variation. So whether repeatability is high, reproducibility is high. So based on that, we can take some corrective action and preventive action. We can provide training. We can coach and counsel our quality checkers. We can take corrective or preventive action. So this is regarding gauge RNR. We are going to do some exercise as well in some time. Before that, let's discuss regarding AAA. So first, let's discuss the theory part and then we will do the exercises. So the next one is AAA, attribute agreement analysis. So gauge RNR is for continuous data. If the data type is discrete, in that case, you would use AAA, attribute agreement analysis. So for attribute agreement analysis as well, there are certain minimum requirements. So the requirements are same. Operators should be 2 at least. There should be at least 2 operators. Sample size is different here. For gauge RNR, minimum sample size is 10. For attribute agreement analysis, minimum sample size is 30. There should be at least 30 parts, 30 products. Then there should be at least 2 trials, 2 or more. And again, masking should be considered. People or operators should not know that we are giving the same part multiple times. Otherwise, they will repeat the same measurement. So these are minimum requirements. If all the requirements are met, we can perform gauge RNR. And from attribute agreement analysis, AAA. From AAA, we get output as kappa value. Kappa value is test value. And this kappa value varies from 0 to 1. 1 represents that there is 100% match. So it's proportion of match actually. 1 represents 100% match. I'll explain it on Excel as well. Give me just one moment. So kappa value is dependent on match percentage. Match regarding repeatability, reproducibility. Let's say there are certain operators. Let's say operator 1 and operator 2. Then trial 1 and trial 2. Let's say we are giving some product to our first operator. So first operator in the first trial, he says product is pass. In the second trial, he says product is fail. What is the match percentage? 0%, right? Kappa value will be 0. However, if in the second trial as well, our operator 1 says it is pass. What is the match percentage? 100, right? So kappa value will be 1. Now let's say operator 2 as well is there. So operator 2 also says in both the trials, product is pass. Here we have 100% match. Now let's say operator number 2. In the second trial, he says it is fail. Manually, you don't have to do it. Just for the reference, I'm explaining it. So in the second trial, operator 2 says rejected, right? Product is rejected. It is not pass. What is the match percentage? What is the match percentage here?
Would that be 50
50%?
75?
or 75?
75. It is
75.
75.
Okay.
75. So here we need to consider both repeatability as well as reproducibility. So if you consider both, it will be 75%. So kappa value will be 0.75. 0.75. So this is how kappa values are calculated. However, manually you don't have to do. You can use some uh, platform, maybe the template that I'm going to share, or Gen AI, or any platform you can use. All right, now let's discuss the
Gaurav,
threshold values. Yes,
I'm so sorry, I had one doubt. So
you can
in
ask.
that previous example, so
Mm-hmm.
let's say operator one passed the product in trial one and trial two, but
Mm-hmm.
operator two failed the product in trial one and trial two.
All right. So
So
here, if you consider repeatability and reproducibility both, match percentage is now 50%.
got it.
Match is 50%. So repeatability, for repeatability, what is match percentage?
For repeatability, it would be 100%.
100%. For reproducibility,
0%.
0%. Now overall is 50%.
Got it.
All right. Now let's move forward. Now let's discuss the benchmarks, threshold values. So whenever kappa value is between 0.9 and 1, there is unconditional acceptance. That means we don't need to take any corrective and preventive action. We can accept our measurement system and we can calculate the baseline or sigma level. If kappa value is between 0.8 and zero point 0.9, again, conditional acceptance, that means based on the criticality, we can take our business call. Either we can accept it or reject it. If kappa value is less than zero point 0.8, there is no acceptance. That means we have to correct our measurement system. Anyhow, we need to complete our project. So we cannot just leave it as it is. We have to correct it. So to correct it, we need to identify who is the outlier, right? Whose kappa value is low, right? Which operator is showing low kappa value. So we need to check that kappa value, and we need to identify the outlier, and we need to take corrective and preventive action. Now we are going to do some exercises. So for exercises, we are going to use LMS. I hope everybody has received LMS access. Please open LMS, everyone. In the meanwhile, I'm also opening it on my system. Please open LMS. So I'll explain the steps to open your LMS. So this particular file, this PDF file you must have received. So you can double click on this link, and then you need to use your email and password. Password is default password kpmg at 123. K is in capital. So this is the password you can use. Your email address that you gave for the registration and the password, default password. You can put it there and log in. Please log in, everyone. I'll pause for a minute. Please log in, everyone. Once it is open, please let me know.
Yes, sir.
Open? Okay. All right, so once you log on to LMS, you will get this particular interface. So here we have a lot of icons, right? So I'll explain or I will give you a walkthrough of this LMS. So the first icon here is for reference material. So this is the same presentation that I'm using, right? So you can launch it and download it. Number two is the prompt library. So for whatever analysis we are doing, right? Whatever analysis we are doing, for those analysis, there are prompts that are stored in this library. Later on, I'm going to explain how you can use these prompts. Then we have certain videos on introduction of Lean Six Sigma, overview, define, measure, analyze, all the phases. For all the phases, we have videos. So you can watch videos, then summary is there. Then we have number 11. 11 is simulation. So simulations are like games. You can play these games or simulations. And in simulations, we have case studies from multiple industries. So based on your industry, you can select two of the simulations out of four. And it is really good. You can explore this. You can play this game kind of simulation. So next is reference material. Again, some handout is there. You can refer to it. Then we have case studies from different domains. We have case studies. So service sector, healthcare, manufacturing, automobile. We have a lot of case studies here. Finance, logistics. Then reference material 19. Reference material 19 is for the exercises. All the exercises you will find here. So you just need to click on launch and this exercise sheet will be downloaded on your system. So you can download and open it. Please download it, everyone. Reference material 19. So you can download and open. So this is the exercise sheet. So you can see a lot of exercises are there. So for descriptive statistics, histogram, normality test, box plot, gauge RNR, AAA, for everything we have exercises here in this sheet. So you can download and open it. Then reference material 20. 20 is the template or the calculator that we are going to use for our exercises. So as I said earlier, as a manager, we have to take decisions, data-driven decisions. We don't have to be masters in statistics. So we are going to use some templates or maybe solutions, platforms, softwares for this statistical analysis. Right? It is not mandatory. Every manager is going to be masters in statistics. So you can download this, sorry, you can install, not install, sorry, download this particular calculator for your statistical analysis. So you can click on launch, it will be downloaded on your system. So you can download the exercise sheet, reference material 19 and 20. Both you can download. Once it is downloaded, please let me know. Reference material 19 and 20, these two you need to download. 19 and 20. Please download both. Done? All right.
So shall we need to open both the files?
Both the files, yes. Please open it. Please open both the files, 19 and 20 reference material. All right. So this one is calculator, reference material 20. So this is the calculator which we are going to use for our exercises. Not only for exercises, for your own statistical analysis, you can use this calculator. Now let's start with the exercises. So first we are going to do gauge RNR study. So on the exercise sheet, reference material 19, right? Reference material 19 exercise. You can see this tab which says gauge RNR, right? So it says a pharmaceutical company wants to know if their newly introduced digital measurement system is accurately measuring the concentration of an active ingredient in a drug. 10 samples that represent expected range of process variation were selected. 3 analysts measured the concentration of each of the 10 samples 2 times per sample in a random order. So the data is for measurement. That means continuous data, right? It is continuous data. Data is continuous. So we are going to perform gauge RNR. And for gauge RNR, there are certain minimum requirements as we discussed. So minimum requirements are at least 10 samples for gauge RNR. So let's check how many samples are there. Parts are 10, right? So first requirement is met. Then there should be at least 2 operators. We have 3 operators. Second condition is also met. There should be at least 2 trials. So we have 2 trials. So all the conditions are met. Now we can perform gauge RNR study. So for gauge RNR study, what we need to do, we are going to use calculator. So reference material 20 calculator. So let's look at the calculator. So here you can see all the analysis are mentioned here. So we are going to do MSA for 2 trials, gauge RNR for 2 trials. So you can click on MSA 2 trials on the calculator. MSA 2 trial. Now what we need to do here on the calculator, we just need to put the data on yellow highlighted area. Yellow highlighted area is for the data. We need to put in some data, right? This is for input. Yellow highlighted area is for the input. So here you can see trial, part, operator, and response. So these we need to copy and paste. So from the exercise sheet, we can copy it and paste it on calculator. Copy and paste. And then here we need to give some inputs. So we need to define how many parts are there. 10 parts are there. How many operators are there?
Three operators.
3 operators. There are 3 operators. Trials are 2. So once you feed the data here, you will see the output. So as we discussed for gauge RNR, we need to check 3 parameters. Percentage contribution, study variation, and NDCs, number of distinct categories. So first we are doing it through this calculator, and then I will also explain how to do it on any Gen AI platform. Right? That will also be explained. So here percentage contribution is 10.67. And as we discussed regarding the standards or threshold values, let's look at those threshold values. So standard says whenever your percentage contribution is greater than 9%, there is no acceptance. So here percentage contribution is 10.67. That means we have to reject this measurement system. Study variation. Standard says whenever study variation goes beyond 30%, there is no acceptance. So based on study variation as well, we are not accepting it. The number of distinct categories are 4. Standard says number of distinct categories should be at least 5 or more than 5. That means we cannot rely on this team, right? We cannot rely on the data given by this team. We cannot rely on this measurement system. So as of now, we cannot calculate the sigma level. We cannot rely on this report. Now what we need to do, we need to identify what is the cause, what is the root cause. So who is causing variation? What type of variation is there? We need to identify. So for that, you can see reproducibility. Reproducibility variation is 7.56. Repeatability variation is 3.10 with regards to percentage contribution. So reproducibility variation is high. Now, it means that our operators are not on the same page, right? Repeatability is not too much, but reproducibility is the majority in the overall contribution, right? So our operators are not on the same page. That means we need to do calibration, right? We need to do calibration. Multiple calibration sessions can be done. Counseling can be done, and then we can bring everybody on the same page. And we also need to identify whether this variation is happening because of the operator or because of the part, right? So what we can do, we can identify which operator is not giving same measurement, right? So these values are for overall team. Once you decide that you are not going to accept the measurement system, after that you need to identify the root cause. You need to identify the outliers. To identify the outliers, you can check individual performances, right? So let's look at the individual performances. So this one, operator number one. Operator number one, you can see here, for first part, he is not repeating, right? In the first trial, he says measurement is 0.65. In the second trial, he says 0.6. So he's not repeating the same measurement. He's showing repeatability variation, right? So you can check who is causing variation, and based on that, you can take your corrective and preventive action against outliers only. You don't have to take action. You cannot put everybody on training, right? Only against outliers you need to take corrective and preventive action. Any question here?
Gaurav, if we look into this now, there's repeatability variance for all the three operators. For few parts they're giving the same this thing, but for few they're not giving the same. So do we go on the frequency of which they've not done the repeatability, or what is the best measurement for this?
Correct. So we can compare them. Who is the biggest culprit, right? Who is the culprit? We can identify that operator, and then we can take corrective action against that operator, or maybe we can provide training, coaching, counseling. That can be done. Any further question, anyone? All right, so this is how we can use template.
I have a
Yes.
question.
Yeah, you can ask.
Yeah, I still haven't understood the concept of outliers. So from this data, can you explain it?
Okay, for the outliers.
Yeah.
All right. So for the outliers, you need to look at the individual performances for operators. So once you decide that you are not going to accept this measurement system, right? So since percentage contribution is greater than 9, study variation is greater than 30, number of distinct categories are very, very low. So we are rejecting this measurement system. Now we need to do the root cause analysis, right? Why it is happening? Who is the culprit? So for that, we need to look at individual operators' performances, right? So for operator 1, 2, 3, individually, you can assess them, you can check their performances, and then you can take your action. Let's say operator 3 is not showing repeatability variation. So you would not take any action against operator 3, right? So if only, let's say, operator 1 is showing variation, you will take action against operator 1 only. So you need to identify who is the culprit, who is the outlier. Individual performance, you can filter out and then you can take your action.
Okay, so I need to check which operator has the most number of repeatability, so that person would be safe.
Correct.
And the one who has least number of repeatability, that would be the culprit.
No,
Okay.
highest variation, repeatability variation will be the culprit.
Yeah, understood. I said the same thing.
All right.
So one more thing, the number of distinct categories is 4. What does it exactly mean?
Okay, I'll tell you. It is actually based on sensitivity of the data. So, however, you don't have to do it manually. I'm just explaining it for the reference. How it is calculating the distinct category, I'll explain that. So, distinct categories actually based on sensitivity of the equipment, sensitivity of the measurement system. So how it is calculating, I'll explain that. So just a moment. So remember we discussed there is overall variation and the measurement system variation should be smaller, right? Measurement system variation should be smaller. We discussed it. So how this template is going to calculate, or how any platform is going to calculate. So these platforms are going to create this overall curve and measurement system curve, and they check how many measurement system curves can be fit within overall variation curve. So that number of curves within this range is called distinct categories, number of distinct categories. So it is how it is calculating it. I'll explain it with some easy example as well. Let's say there is a product. Let's say target product length is again, let's say 10 centimeter. If you are using a measurement tape, and on that measurement tape, there are markings only for centimeter, right? There are markings for centimeters. So within this range, within 10 centimeters, how many categories can you identify with centimeter scale? In how many pieces can you divide it with centimeter scale?
10 pieces would be
in 10 pieces, right?
Yeah.
Right? 10 pieces you can make. That means 10 different categories you can identify. Now let's say we are increasing the sensitivity. So increasing the sensitivity, that means we are using, let's say, millimeter scale, right? Now we are using millimeter scale. So how many categories can you identify? 100, right?
Yes.
So when sensitivity increases, number of distinct categories will increase. We can identify more categories, right? It is dependent on sensitivity of the measurement equipment. I hope
So
it is
it
clear.
means that we are, it means that we are focusing more towards precise measurements. Is it so?
Accurate measurements.
Yeah, sorry.
Accurate
measurements.
All right.
Okay.
I hope it is clear. Can we move forward?
I had just one more doubt. So the standard deviation and the variance are based upon each other, right? So the standard deviation is the square of the variance.
Correct.
So why is it necessary to check both the standard deviation and the variance? By looking at
Okay,
one,
that's a
can't we
very
get
good input. So standard deviation is square root of variance. So when you take the square root of variance, that gives you standard deviation. So here, your observation is absolutely correct. Both will go hand in hand. If study variation is between 0 and 10%, percentage contribution will be less than 1 only. So you are right, just one we need to check. Other will go hand in hand. They will not contradict.
Got it.
All right. All right. Any further question, anyone, before we do next exercise? Just one more exercise we will do, and then we will go for a break. So let's do another exercise for AAA. So do you guys want to do this exercise, or you want a break right now?
So break.
Break? Okay, so let's take a break here. After coming from the break, we will do next exercise. And I will also explain how to use Gen AI for these analysis. Let's take a break. Please come back at 9:30, everyone. 9:30. Thank you all. Welcome back, everyone. I hope everybody's back from the break. Can we start?
Yes.
All right. So before the break, we were doing exercises. So before the break, we did KJRNR. And now we are going to do the next exercise, which is AAA, Attribute Agreement Analysis. And first, we will do it
Yes, sir.
with the help of template, the calculator we were using, and then we will also use GenAI for these analysis. Right? So please open the calculator and the exercise sheet that we were using before. I'm also going to share my screen now. Right. So on the exercise sheet, you need to open this tab which says AAA tab, Attribute Agreement Analysis. Please open Attribute Agreement Analysis. All right, so on this tab, we have multiple appraisers, right? So there are appraisers, 3 appraisers are there, quality checkers who are doing inspection on certain parts. So these are the parts. So there are 50 parts. So for 50 parts, these appraisers or quality checkers are doing inspection, and then they are giving their responses as pass or fail. They are doing inspection and then they say this product is pass or fail. And then we have trials, trial 1, 2, and 3. So they are doing inspection thrice, right? So we are giving one part to one operator thrice. 3 times we are giving them the same part so that we can check if there is repeatability variation or not. Right? And then there is a standard. Standard is the evaluation done by some subject matter expert. So in every organization, there would be some subject matter expert in quality. It may be HOD in quality, or there may be some master QA. So the standard is evaluation done by some master QA or HOD in quality, or sometimes we do a joint calibration with the client as well. So the evaluation done by the client becomes standard for us. So that is the standard here. So here the data type is discrete, pass, fail, pass, fail. It is binary data. Binary data is discrete data. So since data is discrete, we are performing AAA, Attribute Agreement Analysis. So for attribute agreement analysis, as we discussed, conditions are 30, at least 30 samples should be there. We have 50. There should be at least 2 operators. We have 3. There should be at least 2 trials. We have 3 trials. So all the conditions are met. Now we can perform AAA. For AAA, we are going to use the template or the calculator we were using before. So here you can see on the menu, calculator menu, you can see AAA, MSA AAA. So this AAA we are going to use, MSA AAA. You can click on it. And here you can see appraiser, parts, trials, response, standard. We just need to copy and paste. So whether it is exercise or your actual study that you are doing for your project, you just need to paste the data here for appraiser, part, trial, response, and standard. So in this way, you have to arrange the data and then you can paste it here. Whatever data you have, you can paste it here. So let's copy and paste the data. So appraiser, part, trial, response, and standard. So data you can copy and then paste it here on yellow highlighted area. Number of trials, we can check how many trials are there. So 3 trials are there. So here yellow area is for the inputs. So 3 trials. So once you put the data here, you can see the kappa values for the appraisers. Now, for appraisers, you can see here kappa values are 0.88, 0.92, 0.77. So these are the kappa values. Now, as we discussed regarding the standards for kappa values. So whenever kappa value is between 0.9 and 1, there is unconditional acceptance. If it is between 0.8 and 0.9, conditional acceptance. If it is less than 0.8, non-acceptance. So here we can check the kappa values, and based on that we can take our decision, right? Any operator who is getting kappa value of less than 0.8, we need to work with that operator. We need to improve that operator's performance. Right? So this is how we can validate our measurement systems.
Sir,
Yes.
sir, actually just I pasted the data of 50 numbers, and but in my calculator I can't see the kappa values. Have I done something wrong here?
Okay, can you show me your screen? You can share
Yeah,
your screen.
definitely.
I will check that.
Just a second. So, is my
It's
screen
coming
visible
up.
to you?
It's coming up. It's visible now. Please go to the
Yes.
first cell. First cell. Okay. Appraisers are there. Data is already there. Please scroll down. Say. Please scroll down. Go to the bottom. Okay, data is there. You can just close this window. I mean, close this Excel
Gaurav,
sheet.
he's actually just put in the data for only one appraiser. It's not for all three.
Yeah.
Okay, let me check that. Total data points are
Okay, got it,
451. 451.
Yes, Gaurav, I got
All
it.
right.
I
All
need
right.
to means copy paste the whole thing. I thought it
Whole
was
thing. Correct.
repeatable,
Correct.
so I just copied the 50.
All right.
Okay, fine.
All right. All right. All right. So here the kappa values we get, and based on the kappa values we can take our decision, and standards are same as we were discussing. Between 0.9 and 1 there is unconditional acceptance. Between 0.8 and 0.9, conditional acceptance. Below 0.8 there is no acceptance, right? So this is how we can take our decision. We can accept our measurement system or reject our measurement system. So we were using template, the calculator, for our analysis. Now I will explain how you can use the prompt library as well. However, prompt library is for your reference. It is not mandatory to use prompt library for your projects, for exercises, for everything. You can use your own prompts as well. You can design your own prompts. You can uh, use any platform, any maybe ChatGPT or Copilot for your analysis, right? So I'm going to explain how you can use this prompt library for your uh, analysis if you're doing it through maybe ChatGPT or Copilot or any Gen AI platform. So this study material 2, the icon number 2 on LMS, icon number 2 is LSSGB prompt library. So you can click on launch or resume, right? First time it will show you launch. So you can click on LSSGB prompt library. You can launch it. Once you click on launch or resume, it will take you to this page. You can again click on launch. Again on launch or resume. All right. So here, this interface we want. Now here we can select what we want to do based on the phases, based on the DMAC phase we are in. So let's say in define phase. First, I will explain few things and then you can do the exercise by using this. So let's say we are in define phase. So in define phase, we need to first select define phase. Then we get the sub topic, define section. So let's say in define phase, we are collecting VOC. So we can select VOC. Next is topic. So what do we want? Let's say with regards to VOC, something we want. Let's say we are going to collect VOC and we want to draft a questionnaire, right? So for the collection of VOC, we want to draft a questionnaire for the survey. So define subtopic. Let's say survey. We want to do survey. So you can select survey. So once you click on survey, it will give you some generic prompt with some example. So what you can do here, you can use these prompts. So prompts will be suggested, right? So these generic prompts are there, which you can use for your project. However, it is not mandatory. Let me tell you, this is just for the reference. You can refer to it. And at the same time, you can also use your own prompts. So what you need to do here, you can copy the text, copy it, and you can just a moment. You can copy it and you can paste it on Word document, or maybe on email, so that you can insert something. You can insert a scenario. So based on the VOCs that you are going to suggest through your case study, it will generate a questionnaire for the survey. So what you need to do, you need to just copy the text and you need to insert a case study. You can insert case study, or you can insert certain certain inputs from your side as well. So here we need to insert, use the following context. So here we need to insert. We can use one of the case studies we were working on. So I will use case study number 1 that I previously shared. So case study number 1. I'll insert the same case study here. So ABC Inc. delivery case. So I'm inserting the same case study here. Based on the same case study, it will generate the questionnaire. So we just need to insert. So here I have inserted it. Prompt is already there. Now what we need to do, we need to just copy the entire thing along with the prompts and paste it on GenAI platform. Any GenAI platform you can use here. So I'm going to use Copilot. All right. So we just need to select all, copy, and paste. So prompts along with the case study I have pasted here, and then hit enter. Now it is generating our survey, questionnaire for the survey. So it is drafting the survey. We can use this questionnaire for our survey for this case study. So this prompt which is there in the library, this is just for the reference. What you can do, you can write your own prompts as well. You can give the case study to the platform, to ChatGPT or Copilot, and then you can give your own prompts so that it can give you the questionnaire. Right? So you can explore this library for different purposes. Another purpose maybe, let's say in define phase, you want to generate a project charter. So in define phase, you can select project charter and then elements of project charter. project charter template. So this is a template. You will find the templates as well. So you can open it. Now here it is opening up. So for certain topics, it will give you the template. It will let you download that template. So in this template, what you need to do, you just need to paste whatever the content is. Let's say case study, right? We want to give it our case study, and based on the case study, we are asking Copilot to create a project charter, right? So in this particular template, prompts are embedded within the template. You don't have to write the prompts along with this. Prompts are already embedded in this template. However, it is again not mandatory to use template. You can give your case study to ChatGPT and you can ask it to create a project charter with that ChatGPT as well. You can give your own prompts as well. So in the yellow highlighted area, you just need to paste your case study. You need to paste the scenario and then you can save it. And now what you need to do, you need to open your GenAI platform, maybe ChatGPT or Copilot, and then you need to just upload the same template. Prompts are already embedded in that template. You just need to upload that template along with your case study. So project charter template, we just need to upload it and then click enter, hit enter. So based on the case study, it is going to create all the components for the project charter. So business case, problem statement, goal statement, scope. And as I said earlier, disclaimer is also there. So whenever you are getting any output from any of these GenAI platforms, always review that work. Right? Always review it as a subject matter expert, because these platforms may not be the subject matter expert, right? You know your processes the best, right? So you have to review it. Any question here? So you can see here, previously we discussed these business cases. You guys also created your project charter. So here it is nicely done. Losses exceeding these many dollars, right? So cost benefit analysis is also included in some form, right? So losses are given, impact is given very, very clearly, right? In the business case. If you want some refinement, you can also again give some prompt. It will refine. Problem statement, goal statement. Any question here? Anyone?
Gaurav, the
No,
question
sir.
is not exactly on this part, but on the AAA calculations which we did. So during the AAA calculation, we had one more column as the standard, right? So you told that the standard is basically what the subject matter experts or whatever our client is saying. So
Right.
what is the significance of that? That is one thing. And since we're just going with the subject matter or the client's word for that, wouldn't there be a lot of bias in that as well?
Since it is going with the subject matter expert, bias, how the bias is going to be
So
there?
bias as in, so let's say the client, he wants to move the process quickly and he just says, okay, maybe it's just a 0.5 variant, so we'll just go ahead with it. So the sensitivity of it automatically comes down if the client is
So
himself
for
saying that we
okay,
can
for
go ahead with
AAA,
that.
can we discuss it at the end of the session?
Sure.
All right. So I'll take your question at the end of the session. So
Sure.
let's do the next analysis. So let's say now you want to use GenAI for your let's say gauge RNR that we did. through our calculator. Previously, we used calculator. Now let's use GenAI, Copilot, or maybe any other platform you can use. So on the library, you can select your phase. So MSA we are going to do in measure phase. So we need to select measure phase, and then data. So we are going to do data analysis. So measure phase, data, measurement topic. MSA we are going to do. MSA. Under MSA, what are we going to do? Gauge RNR. So in our case study, in our exercise, we need to check how many trials are there. So in the exercise sheet, let's check how many trials are there for gauge RNR. So there are 2 trials. So for 2 trial, we can use the template. So 2 trials, gauge RNR, 2 trials. So once you select 2 trials, a template will be shown here. You can download this template. So once you click on the template, it will get downloaded and then you can open it. Once you open it, you would find yellow highlighted area where you can put the information. So yellow highlighted area is for the input. So you can put the scenario here and then you need to define how many operators are there. So in the exercise that we did earlier, there are operators are 3 operators are there. So 3 is already selected and then we need to put the data here. So actually in this template, the same exercise data is already there. So if data is different, if let's say you are using it for your project, so what you can do, you can copy your project data, your calibration exercise data, copy it and paste it here. So on the template, you can paste your data. And then what you need to do, you need to save this template. Control S, save it somewhere. Prompts are already embedded in the template. What you need to do, you need to go to GenAI platform, maybe Copilot or ChatGPT. You just need to upload this template. After putting the data, you need to upload the template. So this is the template. So you need to upload it and then hit enter. Now it will give you the values for study variation, percentage contribution, number of distinct categories. However, if you are using some different platform, at this decimal places, there may be some variation. Some variation is possible. So that's why I'm saying always validate the output given by these platforms. Right? So to be sure, you can use the calculator. So either you can use this template or you can just give the data to this platform and you can ask manually. You can give the manual prompts. Now it is going to calculate these 3 parameters: study variation, percentage contribution, and number of distinct categories. Right. So here you can see percentage contribution. Just a moment. All right. So percentage contribution for the total gauge RNR, you can see here, 10.66. So as we discussed, beyond 9, we are not going to accept. right? So you will get the output from template, which we were using calculator. You will get the output from these platforms as well. Some level of variation may be there when you use these platforms. Let's say you are using Copilot and then ChatGPT. There may be some variation at decimal places, right? So you can use any of these, either template. In template, there will not be any variation. You can use template without any doubt. When you get the output from these GenAI platforms, you need to validate, you need to use your own process expertise, you need to review it. Any question here? So I would request everybody to explore this prompt library for different purposes. You can use it. This is for your reference. It is not mandatory to use it, but for the reference, it is good. Any question, anyone? All right, now let's move forward. Now let's discuss the next topic. Next topic is regarding the data collection. Now let's discuss some theory part. All right, so in measure phase, as we discussed, we have to collect the data for baselining, for the calculation of current sigma level or current performance for the selected CTQ. So obviously we are going to collect the data, and whenever we are collecting the data, we have to make sure that there is no variation in the data, right? So it should not happen that we are just asking our staff to collect the data. Let's say we are just telling them collect the data. So one person is collecting data for efficiency, another one is collecting data for turnaround time, one person is collecting data from production team, one person is collecting data from quality team, one person is collecting data from the ERP. So there will be variation. So in order to avoid any chaos, we have to define our data collection plan. There should be a standardized data collection plan. So let's discuss what we need to define in the data collection plan. So first, we need to define why we are collecting the data. So the purpose of data collection needs to be defined. Next is what to collect. So in measure phase, probably you would collect your data for CTQ. So you need to define what is your CTQ. Only defining the CTQ is not sufficient. We need to define the operational definition of it. Let's say CTQ is efficiency percentage. So you need to define how to calculate efficiency, because different people may have different understanding regarding same parameter. If we take an example of efficiency, different people would use different formula for efficiency. Anybody who can suggest any formula for efficiency? How would you calculate efficiency? Any formula for efficiency?
Output by input into 100.
Output divided by input multiplied by 100. All right. Output divided by input. Somebody else may say produce numbers divided by target. That is efficiency. Of course, multiplied by 100 as well. Right? So produce numbers divided by a target, that will give you the efficiency. If there is some industrial engineer, they would say efficiency is produced minutes divided by available minutes. So for different people, one parameter may be different, right? They may have different understanding for the same parameter. So only defining parameter is not sufficient. We need to define the operational definition of that parameter, right? So that needs to be defined under what to collect. Next is how to collect. Under how to collect, we need to define whether our executives should collect the data for the entire population, or they should follow some specific sampling technique like simple random sampling, stratified sampling, systematic sampling. So that needs to be defined. We also need to define from where they need to select the collect the data. Right? What should be the source of the data they need to define. So whether they need to collect the data from production team, quality team, from the ERP, so that should be defined. What should be the frequency of data collection? That should be defined. Whether they need to collect the data on daily basis, weekly basis, that should be defined. Once you define all of these things, my suggestion will be to go for a pilot run. Don't go for full-fledged data collection in one go. Go for pilot data collection. Once you get data from pilot run, you can check the validity of the data. A lot of times we get manipulated data from the executives. So always check the validity after going for pilot run. I'll share my own experience with regards to pilot data collection. So recently I did a project for one of the e-commerce giants, and the objective of that project was to improve NPS. For the improvement, I wanted to do 360-degree review for a specific category, product category. So as a part of 360-degree review, I wanted to do telephonic interview with 500 customers. So I collected the contact details of those 500 customers. I created one questionnaire as well for the telephonic interview. I gave the contact details and the questionnaire to two data collectors, two executives. So they were supposed to conduct telephonic interview with 500 customers. So I gave them the details and the questionnaire. Very next day, they gave me the data for all 500 customers, which was a red flag. So within one day, it may not be possible to do 500 telephonic interviews. Another red flag was that they gave me data for all 500. So a lot of customers don't even pick up the call, right? It is not possible to get responses for 100% customers. So because of these red flags, I wanted to check the validity of the data. So I picked up some samples, I called those customers myself, and then I got to know that these two executives did not make even a single call. They filled all the surveys by themselves. So my suggestion will be to go for a pilot run before full-fledged data collection, validate the data, and then go for full-fledged data collection. And before the data collection, you can also train your data collectors on your data collection plan. They should be trained. They should know what to collect, from where to collect, how to collect. So we can provide training. And the last point is ensure consistency and stability. So throughout the project, we need to make sure that we are collecting data from the same source. Source should be same. Unit of measurement should also be same. It should not happen that in the define phase we are collecting data in INR, and in improve phase we are collecting data in US dollars. So we need to ensure consistency and stability in the data. Source should be same, unit of measurement should be same, our approach should be same. So operational definition we have already discussed. So it's a typical template that we can use for data collection plan. I will explain the headers here. So first one is measure. So this is your parameter for which you are collecting the data. Let's say your CTQ. So you will define the CTQ. You will give the operational definition of CTQ. For every CTQ, there must be some target. So you will define the target. Let's say for case study number 1, target for delivery time is 15 minutes. So you will define the target here. Then method or source should be defined. Unit of measurement. So for every CTQ, there will be some unit of measurement. Let's say for delivery time, unit of measurement is minute. So that can be mentioned here. Then comes sampling plan. Under sampling plan, you can define the sampling technique. You can define whether your executives need to collect data for the entire population or some specific sampling techniques should be used. Collection frequency should be defined, as they need to collect the data for every hour, every day, or every week. Right? On daily basis, they need to collect it, or weekly basis, they need to collect it. Then comes sample size. Sample size should also be defined here. And later on, I will explain how to determine minimum sample size for our analysis. Next is reporting plan. So we need to define with whom we need to share the report, when we need to share the report, who is responsible person to share the report. So that is our reporting plan. At last, we have this time frame. Every data collection happens for a specific time frame. Let's say you want to close your measure phase in, let's say, 3 weeks. So probably you would collect your data for maybe 2 weeks or 3 weeks. So time frame should also be defined here. Any question here? Any
So
question?
here, yes, sir. In this table, a header is mentioned as method or source. It is like from where we are collecting the data or what all techniques we are using. Is it so?
Okay. Method or source. So yes, let's say whether we need to collect the data from production team or quality team, or we are pulling up the record from the ERP. So that method and source we need to define here. So which
Okay.
report are we considering? Or we are collecting the data ourselves through some check sheet, or we are asking somebody to share Excel sheet, or we are looking at the dashboard. So that method and source should be defined.
Okay, got it.
All right, now let's move forward. Now let's discuss sampling plan. So for our analysis, sometimes we study the entire population data. Sometimes we study the sample data. Anybody who can explain why do we study sample? Why do we go for sampling? Why can't we study the entire population? Any thought?
So it depends on the quantity of the lot size. Means it can be huge, so we can't assess each and every data. So in that basis, we go for sample, and on that, the nature of those samples, the whole lot is decided whether it is good to go or not.
All right, so you are saying your population may be huge. Huge population, high volumes may be there, so you cannot study the entire population.
Yes.
That's correct. For example, let's say there is a call center. In that call center, they have call recordings for all the calls, timestamps for all the calls, but they would not audit all the calls because of the high volumes. So population is huge. They cannot study the entire population, so they will pick some samples. That's correct. In some cases, population may be unknown. We may not have the data for population. Example can be, let's say, we are launching a new product, and right now we don't know who is going to be our customer or whom we are going to serve in the next 5 years. We don't know. So population is unknown. But we have to do our study. We need to know whether certain features in our product will be liked by our customers or not. So in that case, since population is unknown, obviously we have to study samples. So we can do some survey or interview with some potential customers, and based on that, we can make some inference. So population may be unknown in some cases. Population may be very huge. In that case as well, we cannot study the entire population. In some cases, our study may be a destructive process. So we cannot destroy the entire population. Example can be car crash test. So car crash test is a destructive process. So they cannot destroy all the car units. So they take some samples, they do their test. Based on that, they give safety ratings. Similarly, in electronic industry, in electronics, they do drop test. So drop test is a destructive process. So one of the participant is working in electronic. So drop test is done, right? So they would drop those, let's say, electronic items like cell phone. Let's say Apple iPhone, right? They would drop it from certain height. It's a destructive process. So they cannot destroy the entire population. So they would take some samples and they would study it. So because of various reasons, we study the sample instead of population. So sample is small number taken from the population. That means sample is a subset of the population. And since we are making our judgment based on sample, this sample should be true representative of the population. It It should represent the population. In order to make sure it is true representative of the population, we select or we follow specific type of sampling technique. So there are different types of sampling techniques. Some of the techniques we have in this curriculum. So we are going to discuss simple random sampling, stratified sampling, systematic sampling. However, there are many more sampling techniques like snowball sampling, judgmental sampling. A lot of sampling techniques are there. Here we have 3 sampling techniques. So first one is simple random sampling. Anybody who is familiar with simple random sampling? Any thought on simple random sampling? What is it all about? Any thought?
You just randomly pick
Randomly picking up the samples from the
samples from the population.
All right, randomly picking up the samples as per our own convenience. All right.
Taking the samples and approving with the AQ level.
AQL level?
Particular node.
Accepted
AQL level.
quality level. All right. So I
Yes.
believe in your organization you follow it. So which one do you follow? 1.5?
We are following 2.0.
2.0. All right. You are in electronics industry, right?
No, my automobile.
Automobile. All right. All right. All right. So randomly, without applying any judgment, randomly as per the convenience, we can pick any sample. That is called simple random sampling. So if we are not applying any judgment, every unit in the population, every unit will have same probability of getting selected as a sample. That is called simple random sampling. And I believe most of you would already know it. Here, I'm also going to discuss the conditions where we can go for simple random sampling or we cannot go for simple random sampling. Anybody who can suggest any condition that we should check before selecting simple random sampling?
The population is normally distributed.
Homogeneous, right?
Homogeneous.
Homogeneous. Population should be homogeneous. Correct. That is first condition. Second condition is there should not be any bias. So 2 conditions, population should be homogeneous. There should not be any bias. For both, I will give you some examples. So let's say there is a water tank which you have just filled, and now you want to check the pH level of that water in that water tank. So no matter from where you take a cup of water from that water tank, whether you take it from the top or you take it from the tap, that means from the bottom, pH level is going to be the same. So you can follow simple random sampling in that case. Population is homogeneous. You can follow simple random sampling. So first condition, homogeneity. Second condition, there should not be any bias. So for bias, again, I'll give you some example. Let's say there is a production floor, whether it is manufacturing or service. There is a production floor where 50 operators are working, and then there is one auditor. Auditor needs to pick, let's say, 5 samples every hour. If you observe that this auditor is biased, let's say you are observing this auditor is selecting samples, picking up samples only from female operators or male operators, you would not allow simple random sampling, because in simple random sampling, this auditor would have liberty to select any sample. So there should not be any bias. Or let's say this auditor is holding grudges against certain operators and he is good friends with certain operators. So if certain operator is his good friend, he is not taking any sample from that operator. If he is holding grudges against certain operator, he is taking samples from that operator every hour. So if there is a bias, if there is a possibility of bias, you would not allow simple random sampling. So 2 conditions, homogeneity and bias. Any question here?
So the
All right.
question is
yes.
just a question.
Mhm.
How is the sample size defined? Means when we don't
So in some
know
time we
the
are going to discuss. I will
okay,
explain that. We
okay.
will discuss. All right. So this is called simple random sampling, where without applying thought, we are picking up our samples randomly. So two conditions also are there. If there is a bias, what happens? You would ask your auditor to pick specific number of output. Sequence you will define. Let's say your auditor needs to pick up every fifth output. Whether this fifth output is coming from operator 1 or operator 10, he has to audit it. So this is how you can address bias. So in case of bias, you will not follow simple random sampling. You will define some sequence. And regarding the sequence, I will talk about later. Next is stratified sampling. Stratified sampling is followed where in your population, you can identify stratas or categories. If there are stratas or categories, we follow stratified sampling. And in stratified sampling, from every category, we have to take samples. From every strata, we have to take our samples. Previously, I gave you one example for water tank. Now, let's say same water tank. You have removed water from that water tank and you have filled that water tank with crude oil or any oil. You have filled that tank with oil. And now you want to check moisture content in that crude oil. So for the moisture content, what do you think? Population will be homogeneous or not? Can you take sample from top or bottom from anywhere? For moisture content in oil,
It would be non-homogeneous.
it will be
Oh,
heterogeneous. Correct. Correct.
Heterogeneous.
Right. It will not be homogeneous. Correct. So moisture content will be different at different level. So that is why in oil and gas industry, they would take samples from top, middle, and bottom, and then they will average it out. Right. So if you can identify stratas in your population, you can select your sample, pick your samples from each of those stratas or categories. And that is known as stratified sampling. Any question here? All right. So if it is clear, let's move forward. Next one is systematic sampling. So systematic sampling is where we define some sequence. Sequence as in, let's say every fifth output we need to pick as sample. Every 10th call we need to pick as a sample, right? So we define some sequence. So here you can see to define the sequence, we can follow this formula. So K is the kth unit. Capital N is population size. Small case n is sample size. So population divided by sample will give us kth unit, and that is the sequence. So one example is also given here. So let's say there is a housing society. In that housing society, there are 150 families or 150 flats are there, let's say. And we want to do a survey with 10 families. We want to visit 10 flats. So 10 is the sample size, 150 is the population size. So 150 divided by 10 gives us 15. Right? So 15 is the kth unit. So we can visit every 15th flat. We can do a survey with every 15th flat. And this is called systematic sampling, where we are defining some sequence. Any question here?
How do we define like how big should be the sample? Like how to
Sample
make that
size?
judgment? Yeah,
Are you
sample
asking of
size.
the sample size? I will explain that in some time. I'll explain that. Next topic is that only.
In a warehouse, we follow the root n plus 1 sampling. Means hundreds container, then we sample 10 plus 1, 11 container sampling.
Correct. That is systematic sampling. Sequence we define. Correct. That is a systematic one. Any further question, anyone? So method we have discussed, how to calculate the kth unit we have discussed. However, we need to know the condition as well. So there is a condition that we need to check. What may be that condition? Anyone? What condition do we need to check? before following systematic sampling? Any condition? What about the population? Should it be homogeneous?
Should be homogeneous.
Should be homogeneous.
Correct, correct. It should be homogeneous. For homogeneity, I'll give you some examples here. Let's say scenario is same. There is a housing society. There is a housing society and there are 150 flats and we want to visit 10 flats. Let's say when we go to that society, we identify or we observe that there are multiple towers. Right? There are multiple towers and every 15th flat is on the ground floor. And let's say we are doing this survey for Tata Sky. With this survey, we want to know if our customers are happy with Tata Sky or not, if they are happy with the network coverage or not. So, will you do your survey with only ground level people for Tata Sky?
No.
For the coverage? No, right? It may be possible that network is good on the top floor, it is not good at in the bottom floor, or it may be vice versa. I'm not the expert. So, population will not be homogeneous. In that case, you would not follow systematic sampling. You cannot just do your survey with only ground level people. So condition is homogeneity. Population should be homogeneous. Another example, let's say scenario is same. Every 15th flat is on the ground floor and you want to visit 10 flats. There are 150 flats. But this time you are doing your survey for Pepsodent. You want to know if customers are happy with Pepsodent or not. Will you do your survey with only ground level people for Pepsodent?
Sure.
For Pepsodent, it can be done, right?
Yes.
Population will not change based on the floor, right? So even if somebody moves to the top floor from ground floor, their preference will not change for Pepsodent. So if population is homogeneous, we can follow systematic sampling. Any question here? Right, so if there are no questions, let's move forward. So when to do sampling, we have already discussed. Sometimes population may be unknown, sometimes population may be very huge, where there may be high volumes. Sometimes our study may be a destructive process, so we cannot destroy the entire population. Bias, as we discussed, any bias should be avoided, it should be addressed. If there is a possibility of bias, don't follow simple random sampling. So as some of you were asking about the sample size calculation, let's discuss that. So we are going to discuss how to determine the minimum sample size. So to determine minimum sample size in different industries or different organizations, they follow different methodologies. In some organizations, they would follow certain percentage. So some would say that we pick up 2% as a sample, 5% as a sample, 10% of the lot size as a sample. So some organizations would follow certain percentage. Some organizations would have their thumb rules. Thumb rules like if population is 200, we take 100 samples. If population is 500, we take 200 samples. If population is 1500, we take 400 samples. So like that, they would have their thumb rules. Then some organizations or industries would follow AQL, accepted quality levels. So AQL is a kind of guideline, right? So there would be tables that they would follow. So tables would give guidelines like if lot size is this much, take these many samples. Out of these many samples, if these many samples are defective, reject the entire lot or pass the entire lot. So AQL is a kind of guideline. So that method can also be used. Then there is this statistical method. In our curriculum, we have statistical method. We are discussing just generalized method. Any industry specific method we are not going to discuss because there may be a lot of industries. We cannot cover everything. So generalized method we are going to discuss. So this generalized method is statistical method, and an interesting thing about generalized method is given at the bottom. So in this method, sample size is not dependent on population size. We are not going to consider population size to determine the minimum sample size, because in a lot of cases, you would not know the population size. So as I gave you previously this example where we don't know whom we are going to serve in the next 5 years. So we don't know the population size. Still, we have to do our study. So we need to determine the minimum sample size. So for determining the sample size, what we are going to consider? These three parameters: level of confidence, margin of error, and standard deviation of the population we are going to consider. These three parameters. So first of all, I will explain these parameters, and then I will give you the formula to calculate minimum sample size. So first parameter is level of confidence. Some people call it confidence level as well. Anybody who is familiar with this term? What is confidence level? Any thought?
Well,
If
What
we
is
are
confidence
reaching,
level?
it's
yeah,
like getting a surety that the samples what we choose, the size of samples what we choose would be homogeneous and it would give the results for the entire lot.
All right. All right. So with that input, can we say that confidence level is how much confident we are that our sample is representing true population? That is confidence level. How much confident we are that our sample is representing true population. In other words, we can also say confidence level is how much confidence we want when we are making any inference from the analysis. Analysis will be done based on sample only, right? So how much confident we want to be when we are making any changes in our processes. You will make changes in the processes only when you are confident. If you are not confident, you will not make changes in the processes. So it is that confidence level that you want from your analysis. And this confidence comes from the sample. When sample size increases, confidence level increases. Confidence level is dependent on sample size. I'll give you some example for this. Let's say you are handling a team and there is one subordinate who is not performing well and you want to fire this person. So you are talking to your HR and you are telling them that you are willing to fire this person. So HR says, "Are you sure that this person's performance is not good?" HR says, "Are you sure?" That means HR is asking about your confidence level. So for the confidence, if you say last week this person did not perform well, based on the last week's data, I'm saying performance is not good. So will you be confident or not confident based on just 1 week data?
Not confident.
Not confident, right? That will give you very low level of confidence. So for high level of confidence, you will collect more data. Let's say you are collecting last 3 weeks data, last 3 months data. That will give you high level of confidence. In statistics, for the project management, by default, we choose 95% confidence level. This is the most common confidence level. By default, in statistical analysis tools as well, you will find 95% confidence level. So before making any changes in the processes, you would want to be 95% confident. However, for very, very critical claims, you would choose 99% confidence level. So let's say scenario is same. You are complaining about somebody. Now this time, this is not your subordinate. You are making same claim for your boss. You are telling your HR that your boss is not performing well. So for boss, will you collect only 3 weeks data?
Not at all.
Not at all. You will collect more data because you would want to be even more confident, very, very confident, close to 100% confident, right? So for boss, probably you would collect data for 6 months or 1 year, which can give you higher level of confidence. So for critical claims, you would choose 99% confidence level. And here ZC is the Z critical value for a specific level of confidence. So actually there are different types of tables, Z table, T table, different types of distribution tables are there. Just like log table, there are distribution tables. And ZC value for 95% confidence level is 1.96. And this value is coming from Z table, right? And it's a constant value. This is not going to change, right? So ZC confidence level, Z critical value for confidence level is a constant value which will not change. So we will use this value in our formula to determine minimum sample size. Next is margin of error. So in any process, your customer or the client or the regulatory authority, they would not expect 100% accuracy. Some level of allowance or tolerance will be there, which is called as margin of error. Some margin of error will always be there. Just one thing we need to take care of. Whenever you get margin of error, let's say you are asking your subject matter expert for the margin of error, they say it is 2%. Right? Generally, people talk about percentage for margin of error. But in the formula, you need to use proportion, not the percentage. So if somebody says margin of error is 2%, you need to convert this percentage into proportion. What will be the proportion of 2%? Anyone? Proportion for 2% will be 2 divided by 100.
1 by
So
50.
no, 2 divided by 100. So
Okay.
2 divided by 100 will be 0.02. 0.02. So we need to check error margin of error. So for margin of error, you can discuss with your champion, process owner, subject matter expert. Subject matter expert will tell you what is the margin of error in this process. So we need to use the proportion. Next parameter is standard deviation of the population. So remember, we discussed about how to calculate standard deviation. So that template also, I will share it later on. However, you already have your calculator. With that calculator as well, you can calculate standard deviation. However, this standard deviation is not for the sample. We just need to take care of this thing. It is not for the sample. It is for the population. It is estimated standard deviation of the population. Now the question may be, who will give us? So either you can ask your subject matter expert. So somebody who has seen the process in past, they would tell you the estimate for the standard deviation of the population. If you don't get it from the subject matter expert, what you can do, you can collect historical data. Let's say you have collected last 6 month data, and with that 6 month data, you can calculate the standard deviation. Let's say for delivery time. For delivery time, you are collecting last 6 month data, and with that data, you can calculate standard deviation. But this is not for the sample. Right? So standard deviation will be used, error margin will be used, level of confidence will be used. Once you have all of these three parameters values, you can put these values in the formula and you can calculate minimum sample size. This is the formula. So here small case n is minimum sample size. So minimum sample size equals to ZC. ZC is Z critical value for specific level of confidence. Sigma is standard deviation. In the denominator, delta is margin of error. So we just need to put the values here and we can calculate minimum sample size. I will explain some formula, some example as well. I'll explain it on Excel. And later on, I will share the template as well to calculate minimum sample size. I'm going to share that Excel sheet here. All right, sample size calculation. So first we will discuss regarding continuous data. So this is the template that I'm going to share. You can use the same template. Formula is already there, same formula that we were discussing. So here what you need to do, you need to just put the values here. For standard deviation, Z critical. Z critical is a constant value. Standard deviation and margin of error you can put here, and then it will give you the minimum sample size. So let's say for your process, when you calculate the standard deviation of the population, estimated, right? When you ask your subject matter expert or you calculate it, estimated standard deviation is 2 and the margin of error is 5%. 5%. So in the formula, you need to use proportion. Proportion of 5% will be 5 divided by 100. That will be 0.05. So you just need to put the values here. It will calculate the minimum sample size. We just need to put the values here. All right. So this formula is for continuous data. Now let's discuss the formula for discrete data, and then I will come back to this particular slide, this particular Excel sheet.
Just a query.
Yes, you can ask.
Level of confidence, as you've told that if it is 95%, then the value is 1.96, right? If it is, and ZC is the critical, is it the critical claim for 99% or just 95%?
It 1.96 you are talking about?
No, sir. I'm asking that for 95% level of confidence, it's 1.96, right?
Correct, correct.
And if it is for critical claims like 99%, then does this value change or
right?
it remains
That
the
value
same?
will change. For 99% confidence, value will be 2.575. You can see here. Value is 2.575.
Okay, got it.
Right. So there is a Z table. You can find it online as well. It's a standardized table. All right. Now let's discuss regarding discrete data as well.
So just one question here.
Yes, you can ask.
Can you go back to the Excel sheet that you shared just now, that where you did the calculation?
Okay, this one?
Yeah. So in this, if you look at it, this number sample size you have given is actually independent of the population size, right? Because that's what we discussed in the beginning.
Correct.
Now, even in this calculation, when we did the standard deviation, there was no mention of population size. None of these first rows number 3, 4, 5 don't mention anything about population size. Because it's
Right.
independent. So what
Here,
if the sample
population
size?
size is not there.
Correct. So what if the population size is less than the sample size number we came up with? Like, can such a scenario come up?
All right. It may be possible. It may be possible, especially let's say we are developing some customized ERP for certain organization, right? So population will be very small, sample will be even smaller, right? However, from your sample size calculation, sample may be huge number, right? It may be possible in specific industries, it may be possible. So in that case, what happens? As I said, this method is generalized method. It is not industry specific. So in specific industry like software development, if your population is very, very small, what you would do, you would follow your own method for sample size calculation, industry specific method. So you can go for some, maybe 2, 3. So in software development for persona design, they would do survey with only 2, 3 people, 5 people maybe. Right? So industry specific guidelines are different. This is just generalized guideline. All right. I hope I have answered you. Any further question, anyone? All right, now let's move forward. Let's discuss regarding attribute data. So for attribute data, there is a different formula. This is the formula. Here you can see small case n. This is minimum sample size. ZC is Z critical value, which is a constant value. In the denominator, we have delta, which is margin of error. P is a new parameter. So let's discuss what is P. So P is estimation of proportion of defectives of population, defectives in the population. So it is again estimate, just like standard deviation we were discussing, estimated one. So proportion is also proportion of defectives in the population, and it is estimated. Now the question will be, who will give us this estimate? So for the estimate, what you can do, you can discuss with your subject matter expert or somebody who has seen the processes in past. Let's say your quality head. So if quality has head has seen the processes in past, performance in past, they would tell. So this will be the proportion of defectives in the population, right? Every subject matter expert would know generally what level of defectives we get in the population in the entire lot. They will tell you. If by chance you don't get this estimate from your subject matter expert, what you can do? You can collect historical data. With the historical data, you can calculate the proportion of defectives. Let's say when you collect, let's say last 6 months data, you find out that total, let's say 5,000 products were inspected. Out of 5,000, let's say 40 were defectives. So you can calculate your proportion of defectives. Proportion of defective will be number of defectives divided by total units inspected. So this is how you can calculate the proportion of defectives, estimate it, right? So once you have the estimate, you can put the values here in the formula and you can calculate minimum sample size. Let's discuss one example as well. So here, let's say when you are talking to your subject matter expert says margin of error is 2%. So proportion of 2% will be 0.02. And when you calculate the proportion of defectives comes out to be 0.05. So you just need to put the values here in the formula and you can calculate the minimum sample size. So this is how we can use these formulas. I will share this particular template with all of you and you can refer to it. Any question here? I hope it is clear, everyone. All right, now let's move forward. Give me a moment. I'll just share my screen again. Right. Okay, let's not start with the new topic here because this new topic is regarding the baseline calculation. It will take a lot of time. Let's do some exercises. So please open the exercise sheet, the same exercise sheet that we were using before. We downloaded it from reference number 19, same exercise sheet. Let's do some more exercises. New topic we will start tomorrow. Next topic will be process capability. Let's do some exercises now. I'm going to share my screen again. Okay. So today we discussed regarding histogram. So for histogram, what you can do, you can use Excel. Right? You can use Excel or you can use this template as well, right? Calculator template that we were using. This can also be used. So here it says an engine manufacturer uses a forging process to produce piston rings. The forging process is in control and now the quality engineers want to assess the process capability. They collect 25 samples of 5 piston rings, create a histogram to evaluate the data. So we want to create histogram. So histogram is very easy. You can just go to insert and then you can select the histogram. Or what you can do, you can use the template as well. So let's use template. So you have this template here, histogram. So calculator menu, then histogram. You just need to copy paste the data. Copy and paste. Now this is the histogram from the data. Now, what is the inference? What do you think? Data is normally distributed or non-normal?
It's more or less normally distributed.
It is close to normal. All right. So it seems like a normal distribution. However, there is a confusion, right? We cannot be very sure by looking at the histogram. Right? It gives a rough idea regarding the characteristics of the population or sample. Any graphical analysis will give us rough idea. So to be sure, what we can do normality test. So there is a test called Anderson-Darling test for normality. So that test is also there in the calculator. So normality, you can see normality test, and the name of the test is Anderson-Darling test. So with the same data, we are going to check normality. So you can click on normality, and then you can just put the data here, copy and paste the data. Same data, copy and paste. So once you copy the data, it will give you p-value. Inference for the normality will be dependent on p-value. Here we need to check the p-value. So inference will be based on p-value. If p, so this is a thumb rule that you can take for now. Later on, I will give a detailed explanation on what is p-value, why we are uh, making such inference. So whenever p-value is greater than 0.05, if p-value is greater than 0.05, we can say data is normally distributed. For now, you can use it as a thumb rule. Later on, I will explain it in detail. I'll explain what is p-value, why we are comparing it with 0.05. I will explain that. So this data seems to be normally distributed because p-value is greater than 0.05. You can check the normality by using GenAI as well. But in GenAI, what happens in most of the platforms, those platforms will tell you p-value is greater than 0.05 or less than 0.05. Until you ask them to give you exact p-value, they will just tell you less than or greater than. All right, so the inference is data is normally distributed, right? Any question here? No? All right, now let's do another exercise. So let's say with the same data. Yes. Yeah, you can ask.
Sir, if you can just tell, what exactly is p-value in short terms, means how can we practically
Okay,
understand
I'll
it?
give you a high level overview of p-value. So p-value is actually probability. It is probability of getting same data again and again in future if null hypothesis is true. Since we have not discussed hypothesis yet, so that's why I'm not explaining it in detail. So P is probability. You can take it as probability. And 0.05 is called level of significance. Later on during analyze phase, I will explain it in detail. P is probability, 0.05 is significance level. Any further question, anyone? Now let's do further analysis. Let's say for the same data, let's say this exercise that we were doing. Let me open that exercise sheet again. So same data, this one, diameter data. Let's say for this diameter data, you want to calculate mean, median, mode, variance, standard deviation. So previously we used some template, we did manual calculation, right? So we can use this calculator as well to calculate descriptive statistics, right? For descriptive statistics like mean, median, mode, standard deviation, variance. So what we need to do, we need to just copy the data. We can go to calculator, menu, descriptive statistics. If you want to calculate just the descriptive statistics like mean, median, mode, standard deviation, variance, you can click on descriptive statistics and then you can paste your data. It will give you the statistics, mean, median, mode, range, variance, standard deviation, everything you will get. Any question here? All right, so this calculator can also be used for your standard deviation and variance. Now let's do one last exercise for today.
So a short query. In the descriptive statistics, it is in the last row, it shows sum of squares. Means how this data can be useful? If you can give any inference.
Okay, sum of squares actually for this, I mean, whatever exercises we have done so far, for those exercises, it is not relevant. Sum of square will be relevant. I'll explain you. I mean, I'll give you some scenario. Let's say you want to convert some non-normal data into normally distributed data. For the transformation, sum of square will be needed. Right. So in certain exercises, in certain statistical analysis, sum of square may be needed.
Okay.
So square for all the data points and then sum of it. That is called sum of squares. So for transformation purposes, it may be needed. Now let's do next exercise, which is for box plot. So on the exercise sheet, you can see here histogram, box plot group. Just a moment. Team 1, team 2. All right, so we are going to create box plot. Today we discussed about box plot. So there are two teams, team 1 and team 2. So team 1 and team 2, for these teams we can collect the data, right? And we can generate box plot. I mean, we just need to copy the data. So let's say time, we can use calculator. So let's say one team. So this team. So this one is team 1. So for team 1, team 2, we can just copy paste the data and we can look at the box plot. So box plot, as we discussed, would show you if there is any outlier, right? It will show you the outlier. It will show you the median, right? So by looking at the outliers, you can make some inferences, right? And by looking at the IQR as well, you can make some inferences. Let's copy team 2 data as well. Right. So if there is any outlier, that will go beyond the adjacent limits. Let's say if in case there is some outlier here, so you will do the comparison based on number of outliers and IQR. So IQR is this quartile 3 minus quartile 1, 31 minus 17.5. right? So this is how IQR and number of outliers, based on these two parameters, we can do the comparison. However, it is not mandatory to use this calculator for each and everything. What you can do, you can go to insert and then select box and whisker. Select the data and use box and whisker plot. So you will find all the options here. Box and whisker plot is the name in Excel. Right? Any question here? So please explore this particular template and the library as well. You can explore it. If you have any question, you can come back and let me know. We can discuss about it. And we are going to start the next topic tomorrow because that will take a lot of time. And before we wrap up today's session, I believe somebody was asking something. There was a question. Somebody wanted to ask something. I asked them to wait.
Yeah, Gaurav, yeah.
Yes, Vaibhav.
This was regarding AAA, which we worked out.
All right.
So in that AAA calculation, there was this particular column called standard.
Standard, yes.
So what is the significance of that standard?
Okay, I'll explain that. I'm sharing my screen again. Okay. So this is the exercise, right? You're talking about this column
Yes,
E.
yes.
Column E. All right, standard. So standard is evaluation done by some subject matter expert. In some organization, they would call it master calibration sheet. Are you familiar with master calibration sheet or legend? They would call it legend or master calibration sheet.
Okay, but what significance does this have to this study is what I wanted to know.
I'll tell you.
Yeah.
I'll tell you. So first of all, we will give these parts, all parts, to some subject matter expert. So subject matter expert will do the evaluation done by the subject matter expert or the master QA is called standard, right? Now, everybody should match with the standard. That is accuracy. When we meeting the target, when we are close to the standard value or the target value, that is accuracy, right? So kappa value will be calculated based on accuracy and based on precision both. Now the question may be, what is the difference between accuracy and precision? I'm going to explain that. Give me just one moment. I'll share another screen. So kappa value will be calculated based on two things, accuracy and precision. So accuracy is where our process or the performance is close to the target. So here you can see high accuracy. So if we are close to the target, that means we are accurate. Precision is when our process is consistent, right? So here you can see high precision. So these data points are not close to the target. That means accuracy is low, but there is high precision because process is consistent, right? All the data points are close to each other. That means process is consistent, but data points are not close to the target value. That means accuracy is low. So standard is the target. So everybody should match with the standard, that is accuracy. And there should not be repeatability variation as well. That is regarding precision. Every time we need to repeat the same measurement. We need to give the same output. If I'm saying product is pass, every time it should say it is pass. So that is precision. So we should be accurate and precise both. So that's why we check against the standard as well to check the accuracy.
Got it.
Right.
Sir, here
Any
in a
other
way,
question?
here in a way which you have mentioned that regarding accuracy and precision. If I'm correct me if I'm wrong, accurate data points must be precise, but precise data points may not be accurate. Is the statement correct, sir?
Okay, accuracy may be high along with low precision. It may be possible. So here you can see accuracy is high. All the data points are close to each other, but they are not close to each other. It may also be possible. Or there may be low accuracy or low precision. Ideal state is this one. This is the
Yes.
ideal state.
Yes.
High precision or high accuracy.
Mm.
Any
The fourth
further
one may also be true regarding its accuracy.
Can you
Because
please
it's
repeat? What may be true?
I mean to say the fourth stat which it is shown in the diagram, this
Mhm.
may be true with respect to
It may be
accuracy
true.
and precision also.
Yes, it may be true. Yes,
Okay.
it may be true.
Thank you.
All right. So thank you everyone for your active participation. Tomorrow we will start same time and we will discuss regarding process capability and how to calculate sigma level. All right. Thank you everyone.
Thank you.